the conference and showing your interest in what we have done, because that's what we will start with today. Yesterday you saw that we had a number of more higher level presentations of what the pilots had been doing together with EXO, and we had some discussions on where we think we should go at European level. So we were more looking outwards and upwards as pilots based on what we have developed and the discussions we have had. But now it's time to really start looking inwards and really showing some of the results that we have achieved within the different pilots. And that will be exactly the topic of the first session. So in the first session, we will have 4 presentations, one from each pilot, in which we will present our research results. And so every pilot will present separately. There's been a presentation on the focus group yesterday, which was more inter-pilot. But so now we will really discuss per pilot what are the results that we have achieved, and we will show some of those in the first session. Then we will have, in a second session before lunch in the morning, we will have a presentation from the different pilots again on the verticals. How did we address the verticals? Which verticals did we address? How do we see that? How do we see our role with regard to that? And then we have time for lunch. And then after lunch, we will have a presentation from ENISA and JRC, which we had a very close collaboration with, working on the roadmaps, but also working on the Atlas. And so we will have some presentations on those, which are certainly very interesting to communicate to all of you, so that you know about them and that you can ask questions on where they intend to go and get their vision on that. And then finally, we will have a presentation on road mapping for the future. So on the roadmaps that we developed, those will be presented more towards the end of the day. But so I suggest that we start with the first presentation in the first session on research results and demonstrations. And the first presentation will be given by Antonio Skarmeta from CyberSec for Europe.
Okay, so first of all, can you hear me? This one? Okay, yep, perfect. I think I have, my voice is not a problem. So first of all, thanks for the, in this case, for the organization, basically, I was at. I'm quite happy after I was at more than 1 year, I was at, or 2 years, not being physically meet and coming here to Brussels, I was at. So it's very good for all of us, I was at. So as was said, basically, in my case, I wanted to present what have been the main, I was at, activities linked to the research activities or the research, I was at the framework, as you will see later, that we have created as part of CyberSec for Europe. My name is Antonio Skarmeta, coming from the University of Murcia, and I have been, during the last 3 years, mostly the leader of the Work Package 3 in CyberSec for Europe. That, as you will see later, covered all the, I was at the research activities linked to the development of solutions and providing new building blocks for the cybersecurity. Okay? Okay. So as mentioned, as yesterday was shown by Kai, I think one of the characteristic of CyberSec for Europe is that apart from our organization, I was at on different main activity streams. I was at specifically in the area of research and innovation. We have a very close collaboration between 3 work packages, as you can see here. That is what is called the Work Package 3. That is the blueprint, design, and common research areas. The one about development of the roadmap, and also the demonstration of a case of verticals, basically in our case. And this is significant, as you will see later, because what we have tried to create is like a synergy, very clear between all the different activities in order not to just do research without having in mind what could be the result of this research, but also to try to integrate the research that we are doing in the verticals, in the pilots that we are trying, that are assessing certain kind of verticals and industrial sectors, I would say something. So the idea is, like I think it was Gabia, and was also Martin just mentioning, a little bit to think about not only about the actual design and the future, but also how this can be integrated, I would say, on the industry in Europe, I would say something. Okay? So, it's the other way around. Sorry, yeah. Okay, so basically regarding that, as you can see here, and you will see later, the research activity in CyberSec for Europe has concentrated around 10 different tasks. These tasks, as you will see later, data are mapped to the different verticals, I was said, in the connection of this collection of, I was said, links that we already created. But here you can see more or less the main ideas that each of these tasks already were focused on. No? For example, we have a lot of research on identity management, on authentication authorization. We have in usability and certification framework. And you will see later when also the presentation in some of the topics about methodology for doing certification, automatic verification, GPR compliance methodologies, and so on. But the main idea is that although you can see here that each of the tasks are concentrated on one topic, the main idea was to try also to converge them, to make them collaborate, the different tasks, in order to try to identify some kind of scenarios where we can put together the results of the different tasks in order to really create, I would say, some kind of a framework that can solve specific problems in that sense. So for doing that, at the end, what we have created is what we call a functional architectural or cybersecurity architecture, where we already try to position the different assets that we already have bring to this through these different tasks. As you can see here, at the end, during all the 3 years, 3 years and a half, basically, we have worked on around 75 different assets. Later, some of them are evolution of the initial one. And at the end, the main idea has been to see how all these elements are not individually conceived, but they are part of a more broad, I would say, vision of how to solve problems in the sector. And additionally, some of them already have been integrated on the verticals, I would say, in some sense. So they have been demonstrated individually on blocks, but also they have gone to the verticals and put them as a solution in order to bring them. So here you can see more or less, I'm not going to go into data, but because later you will see that. Here you have the 10 lines that we have, where we have not only research on concrete assets, but also, for example, we have scouting. So we also do some kind of analysis of future trends, new solutions, and how they can affect the roadmap that we are creating in that sense. So having a midterm, I would say, vision. Also aspects like impact on society of the solution of the cybersecurity, for example. And at the end, what I mentioned, the important thing was to also have in mind the demonstration side, the pilots, in some sense, where we can basically provide this kind of solution. This is basically the architecture. So basically the main idea was, okay, as I already mentioned, the assets are not individual elements, but basically they should be part of an architecture, a functional architecture, I would say, in some sense. So where you can see with the different color, the different tasks, and how you can see here, basically the kind of interactions that we already envisioned, with the idea that interaction later, as you will see on the platform that we already have created with all the results, we are showing and we are demonstrating how these connections are possible based on some kind of scenarios that are small demos, if you like, where we are putting all together all these elements. At the end, the important thing here is to have some kind of adaptive security that can be instantiated on different way, depending on the needs of the problems, of the verticals, of the pilots, and so on and so on. I was saying something, okay? So this is a little bit the idea. So we have here, I mean, in the middle line, you have the verticals that later will be explained, some of them in details. And here you can see basically all the others. So there are software assets that are giving the roadmap, that are providing the vision, and how them are needed to be integrated. And here you can see basically, I mean, not going to go into data, but just to show you, this is, for example, the concrete assets that are already integrated as part of the pilots that are being developed in Work Package 5, in the verticals. That will be the main topic on the next presentation. I think that the most important thing here now, and here is this like the presentation to the world, I would say in some sense, we already have tried to gather all our results in a way that can be easily understand, and where we can provide as much information as possible about how to use them. So we have created a GitHub. Here you have the website, and basically the idea is that there we have create like a double entry table where you can go through the different tasks, check for each of the tasks which are the assets, which are for different assets. You can see videos, you can have papers associated to that asset. You can see also scenarios where these assets already have been shown how to be integrated with other assets of that task or from another task, I would say in some sense. And at the same time, what we have created is following the work that we carry out together, all the pilots regarding this roadmap. We already have created another entry where you can see how these assets map to the common roadmap. in that sense, so that you can see, okay, what we understand we are able to provide in the context of infrastructure protection, in the context of holistic data protection, in any of them, I would say. So you can basically see our results already are based on tasks, based on also on building blocks that we understand can be seen in that sense. So we have a double entry, so you can see later, if you go there, I mean, I'm not going to go into, but basically the main idea is that here we will try to maintain during the lifetime of the project, obviously, all the updates of the assets. In some of them, obviously, you have access to the source code. As I already mentioned, you have videos, you have papers, you have guidelines, etc., about how to use them in that sense. Okay, so here you can see, for example, a way to represent it. Here you can see the assets, and then from the assets to which of the building blocks they can be considered as a solution that can be used in order to solve the problems or the challenge that already we have linked to that area, I would say. Also, we have tried to indicate, for example, which document that we already have generated describe, for example, the usage of assets that can be connected to that building block in that sense. So it's a way to facilitate, basically, people that are interested in results, how they can see our work, and with the idea to, obviously, as I already mentioned, to update it during the lifetime of the project as soon as new solution or new, I would say, papers appear regarding to the result. Here you can see another way, basically, as you already said, either from the conceptual way, either from the different, I would say, the collection of tools associated to a certain building block. So basically, that's one important thing here is, and this is that's why we wanted to present today here. It's something that obviously we open and we offer, all our brother pilots basically to try to check a look there maybe, and we can see the synergies between us regarding the possible collaboration regarding the results that we are generating. And finally, I think what's important, as I already mentioned, is, I mean, if you have something in detail, something that you want to know in detail, you can go there and check, because I think the information is quite extensive. I think that the important thing here, as I already mentioned, is that, as I already said, we haven't created these assets only as a isolate result, I would say. Some of them maybe are isolated because maybe it's an algorithm that already has been defined for certain issues, but in general, the main idea has been to see, okay, these assets need to be part of a solution, I would say. And that's why basically now, I'm trying not to overlap what is going to be the next presentation. I try to show you some examples about how we have done this in that sense. So, for example, regarding the identity management, as I already mentioned, we have a considerable number of assets that are linked to access control, privacy-preserving identity management, to aspect regarding the GDPR control, basically, of the data, and so on. No? So we already have tried to identify how these different assets can be applied, for example, not only in the smart city, but, for example, you will see in task 3.4 and 3.2, where they try to apply this to the smart campus, like a small, I would say, reduces the scenario, if you like, in that sense. No? So in that, here, for example, and just an example of the scenarios that we envisioned here, you can see that we already have tried to integrate a new approach to the privacy-preserving identity management through the integration of a distributed identity provider that is able to manage and control the attributes that are being disclosed from the user, with the connection to the ADAS, so that external user, for example, in this case of a city, can come to a city, get enrolled in the city platform, in that sense, using his electronic ID, and based on this, enable to decide which attributes of the one that he is already able to provide are going to be used on the interaction with the city, depending on the kind of services, and so on, so on. No? The same to the campus. And with the idea that everything of the procedure, or the interaction, etc., are trustable, because at the end, we also have a DLT behind that is trying to monitor the different, I would say, components, interactions that are happening on that scenario. No? The other one, for example, is, as I already mentioned, for example, for authentication and authorization, we already have integrated different components in a scenario regarding video surveillance in order to identify and to control, basically, first, the authentication using passwordless authentication based on FIDO, having a secure cloud-based storage of the information, having access to manage the different devices, and being able to control who can access and what is the information that is being provided, linked to as already mentioned, the access control mechanisms that also are connected to the GDPR compliance modules that are able to check that everything is being done according to the user, I would say, expectation, I would say something. So at the end, the main idea, as you can see here, is to put things together just to validate them in a more credible and real scenario, I would say. For example, for data protection, here we have extend, in some sense, a solution like a ShareMine already been provided by some of the partners in order to have secure multi-party computation, so that can be used for the data exchange of critical information between certain entities. In this case, as you know, we have a pilot on the banking sector, where basically certain information like the IBANs, etc., are something that need to be controlled in a certain way. So basically, we provide this kind of solution, included some kind of reputation mechanism, so that the different entities can be aware of what is the kind of elements data that they are exchanging in that sense. And finally, I was just to conclude my presentation, just to show you one of the scenarios. I think that is also connected to the work we already have carried out with Concordia. We are still on, basically, by the way, in the sense. Also, we have started some discussion also with ECHO, in that sense, in order to create an ecosystem of different entities, in that sense, that are able to share information in a privacy-preserving way, based on the integration in the cyber threat intelligence platform. In this case, we're using Mees in the scenarios that we are talking about between the different pilots, in order to decide, in certain case, how to anonymize certain of the attributes that are going to be shared in the IOC. In other case, how to create some privacy exchange, and additionally, as you will see also, you can see also in the other picture, the possibility of using federated learning as a way to aggregate information locally, so that we can share not data but models between the different entities, so that each entity not necessarily need to see in detail the data that are going to be need to be exchanged between all the different, I would say, partners. This is being applied concretely to the scenario of the banking between Concordia and CyberSec for Europe, because we have a similar pilot there, and with the idea to basically validate as an alternative to the existing method to sharing of that information between the banks. In that sense, okay? In that sense. Indeed, this is quite aligned with some effort that already the banks in Europe are trying to do, using this kind of platform in order to do this sharing of information using technology like the one I already mentioned in that sense. So basically, I think it's something that we can support, that we can give, I was at good examples of how it's worked. And by the way, as I already mentioned, we already have, for example, worked with ECHO on also to integrate this with the early warning system that they already have. So in that way that we have a connection of the incident report plus the integration of the incident between, or the data of the incident between the different pilots in that sense. Okay? So basically, as a conclusion from our side, and I think this is important, it's one of the main, I would say, results that also yesterday were mentioned. No? We have been able to create synergy between the different, I would say, cybersecurity groups in Europe, I would say, based on not only on research publication, but also in the creation of real interaction between assets that are already being provided by them, and how they can be integrated and used on scenarios like the verticals that we have in our case. So also that implies collaboration between the academia and the industria in order to really generate valid solutions that later can be spin-off, I would say, in some sense, and being created in a real product, I would say. We have created this Hit Hub, as you mentioned, where we try to expose the results. Obviously, always we can improve it, but the main idea is to have something where, okay, you can reflect very easily what you can see basically, and CyberSec for Europe can reflect very easily what we have done, for what is the results that we have there, and how this map with the future a common roadmap that already have been created between the different pilots. We have created collaboration, and that's, as I already said, I think that is good, and something I would say it will continue, at least from our side, until we finalize the project, I would say, in that sense. And basically, as I already said, I think it's one for me, it has been one of the most also relevant part is that at the end, based on what we have done in CyberSec for Europe, based on the collaboration and the exchange, more than the collaboration, the exchange of ideas with the rest of the pilot, we have been able to identify what could be this research roadmap for the future that will, I would say, put some sense, Europe in front of the research on the cybersecurity area. And that's all from my side. Thanks you very much.
Thanks, Antonio, for a very interesting presentation. Each time that you present your results, I'm always impressed by the progress that you made and the strategy that is behind it. Does anybody have a question from the audience? Nobody? Okay, well, I have one question. I really like the concept that you put everything in a GitHub where it's accessible to everybody. You said some of the source code is in there as well.
Yep.
Can you say to what extent is that almost all of the source code, half of it,
I mean,
a small part of it?
I would say that, I mean, I cannot tell you exactly, but I think that more than half of it is already open source. I would say.
That's really
yes.
nice.
I mean, it's very limited, the number of code that is, at the end, already have not decided to be open source or not, I would say, but I think more than half of it is already open source.
Yep. Excellent. Because of that, because we like open source, I'll give you a box of chocolates.
This is not.
So the next presentation will be from Concordia and will be given by Antonio Iannillo. Floor is yours. Do you want some still water or sparkling water?
Oh, not now, maybe later. Thank you. Okay. Good morning, everybody. So I'm going to present a bit of the research from Concordia. So it's our first work package. My name is Antonio Iannillo. I'm from the University of Luxembourg. Actually, I have to be honest, since from the beginning with you, I'm not the one who prepared this presentation. I'm just like here as a replacement. So if you have like any question at the end, like more specific on our results, our work package leader is Hurkan Schobwalder from Jacobs University. I will give you like the mails anyway at the end of the presentation. I thought it was a tape not to press there, no, opposite way. Okay, perfect. So for double P1, we split like the research like in 5 different tasks in according like to which specific area we are focusing on. So starting from the very bottom, we have like the device-centric security, where we are focusing more on device, on the hardware. Then going on top, we have like the network-centric, system software-centric security, application data-centric security, and of course, like on top of all of them, we have like the user-centric security. So starting like from device-centric security, you can see here like the list of research activities. We have like hardware-assist security mechanism like trust zone, SGX, some efficient cryptography primitives work, so trustworthy IoT system and protocol, some device analytics for detecting anomalies, and then blockchain technology applied to IoT scenarios. As an example, you can see here like what we did like for the MQTT protocols. So the real problem was like that all these sensor IoT networks sending data through the clouds using MQTT, and of course like there is like a limited user controlled access for this. So what we did, we had like this attribute based access control from MQTT, these frameworks, and so the experiments show like a reasonably low enforcement overhead. Here you can Did I press something wrong, Frozen? No. Voila. Here you can have like some highlights on the publication that we did like this last year. Then passing through the network-centric security. So our research activities mainly like goes around like distributed denial service attack, the analysis of encrypted network traffic, and software-defined networking. Here we have like one example of our work. This is like the DDoS amplification. Of course, like this is widely used like for DDoS attack. And we made like some observation. Of course, I mean, our approach like was like to these honeypots that we locate at the edge of the networks. And we had like these different observations. So different vantage points are mostly this joint set of attacks. And then the fact that the attackers were able like to detect abusable amplifier quickly and adapt quickly. And here we have like some publication highlights. Then for our third task, we have like, as I said, like the network-centric securities. We focus on more like on security by design, some analysis on the dynamic analysis of malwares, I mean from University of Lorraine, system security validation and 0 days, and then resilience of drones, UAV. So for example, like here we have like the packet malware analysis. So as we said, like we have like obfuscation that usually hide like the API used by malware. So our approach was like to reconstruct like this import table from Windows via the API micro execution, and we implemented like the API X-ray producing like the standard for the PA files of Windows. So we were able like to successfully rebuild like more than 150,000 executable malware programs and improve the detection rate like of unknown or new malware variants. And here you can have like some highlights of the publication that we had. Fourth pillar then we can say is data application-centric security. Some of the research activities are like the protection of data with a special focus on the big data, protection of cloud services, and some application behavioral analysis. Here we have like an example, like the assurance-based and risk management framework. So the risk management frameworks from the 90s, of course, where they were limited, and there is like more complexity now because of like IoT and cloud systems. So the approach that we use here is like integrate like the risk management process with the assurance technique, and in order like to correct the behavior of the target system. Some application that we had like with this research is evaluated like simulated industry 4.0 scenarios, and some detection of discrepancy between what is believed is a risk and what is the actual risk mitigation. Here we have like some publication highlights again. We go like for our last pillar. Our last task is the user-centric security, where we focus more like on privacy protection and risk evaluation, the identity management, and then what is going around on social networks and fake news. And here we have another example, like misusing mobile sensor for data exfiltration. So mobile sensor leaks sensitive data, and we have like a limited access control. So the research question here was like, can advertising be used to deliver attacks? And here we have like some of the results of the discoveries, and actually the answer is yes. The advertising ecosystem can actually deliver like some stealthy attacks. We have like flows in Android that are enable to persistent data exfiltration, and they also like leak data not only from the different store, but also like from the different sensor, for example, like the motion sensors. And here we have like other highlights. So being like very quick, we are covering like several aspects. I try like to give like you a quick list, but I strongly suggest you like to go on the CONCORDIA website. We have like a full list of publication divided and split by the 5 different domains that I've just presented here. Just like a little note, I mean, of course, like there is a strong link between also the other work packages of CONCORDIA, especially what we are going to see like this afternoon with the work package 2, so the industry pilots, the vertical pilots, and of course, like with the other pilots, as like my colleague before said. And just a little note like of what happened like with COVID. So we had like not a big impact on the research itself. I mean, the only real problem that we had like the different to create like some space for creative moments. That means like, of course, like our researchers were working, but we're working like in their own labs. We didn't have like exchange like before like a meeting, but this is something that fortunately like this year has changed. And as I said from the beginning, if you have like any other question regarding these topics that I presented, anything like you can write an email to the leader of the WP1 or like to the task leaders as well. That's all for me. I took like less time that I was scheduled.
For the presentation. I don't know if there's any questions from the audience. Yep, go ahead. If I can. Just try. If you speak up loudly, I can repeat it in the mic.
Okay, here we go. So Thomas Jensen from SPARTA. I just wanted to know, did you consider sort of the security of these operating systems in IoT devices? You might have said this, but I can't remember.
No, I didn't get the question. So you consider security?
So that you had these different levels,
yes,
and at
sure.
the IoT level, the operating system, did you look at the IoT operating system security? And
yeah, I mean, that it depends like from which point of view you are considering like the IoT. If you're just considering like the hardware assisted part, so like where we are to consider the secure firmware like Trust Zone or SGX, we're talking about the task 1.1. So we are considering like that point of view, like how secure is actually the software using this particular hardware capability. If you're talking about like the OS, so real-time operating system, firmware and stuff like that, we're focusing more like on the third task. So or everything like the malware analysis on the OS. So the software abstraction of the operating system is considered more like on the third layer.
Okay, thank you.
Does this reply your question?
Yeah.
Okay, perfect. Thank you.
Any other questions? You talked about resilience of drones on your slide.
Yeah, we have like indeed like one of our vertical pilot. I mean, I think we're going to have like a brief presentation. Okay. Is like this UAV resilience, like in one of our partners is Airbus cybersecurity. So we were considering like how actually this UAV will communicate to each other, how the UAV will communicate with the base system. Yeah, the base station. Sorry, with the base station, and then like. Of course, like they have to be resilient. So we were considering like how to, what kind of security mechanism we can implement out on the UAV that anyway like has reduced constraint. I mean, has some constraint, reduced the memory, reduced capabilities, and yep, this is like more or less like the topic.
Okay. I had the impression from what you presented here was low TRL work that you did. Is that correct, or is it rather higher, or there's some parts of it that are higher TRL?
This I cannot really tell you. It really depends from the research here. But okay. For the industrial pilots, I'm pretty sure this afternoon they will give you like more information, especially like this question of the UAV or whatever. So they will give you like more. But it really depends from the research. I mean, we go like, of course, from TLR1 to 6, 7. I mean, the malware analysis I think is like almost like in commercial use, but I'm not sure about that.
Good. If there is no more questions, thanks again, and I'll give you a box of chocolate.
Yeah, thank you. Yeah, thank you.
So the next speaker will be Augustin Lemesle from SPARTA, who will be presenting the work done by SPARTA. Augustin, the floor is yours.
Thanks.
You want some water?
Oh, no, I had a glass. I will take my glass. Yeah. Okay. Does that work? Or? Yeah, okay. Wait, my slide. And it's a green one. Okay, thanks. So, hi everyone. I'm Augustin Lemesle from CA and SPARTA. So, I kind of realized that I did not include a high-level presentation of the 4 programs that we have in Sparta, but I guess I already did that last year when I was in remote with the light, the sun behind me, and I was all dark. There's a pretty picture on Twitter of me. You see nothing but darkness. But the idea that I wanted to do today is just take one of the programs for Sparta and detail that one a bit more instead of going on the 4th program. And maybe you remember from yesterday, Florent detailed 4 questions that we detailed for the Sparta pilot, and these are the 4 questions that were the source of the 4 programs in Sparta. And the one I want to address is a bit shortened here, how to trust AI, but how to produce a secure, reliable, fair AI system for citizens. So the Sapphire program, in short. Bit of context here, and the context is from 2018 when we designed the program, but also it's still remains a lot more visible nowadays, that AI is now everywhere, much more widespread. Industrial are starting to use that, and well, people don't know what's working. People want to use it in safety critical system, but is it possible to use something we don't understand? We're not sure of how it works behind and can't explain how it works in safety critical system. Do we have any trust in that? That was the big question of the Sapphire program, and actually it still remains today as a big question. We brought some answers, but still it's a big topic. And so that brought us to other things to consider on AI system than just good accuracy on the system. That's the first metric you want. You want your AI system to be very accurate and stuff, but actually now we need to have other metrics on this AI system to be able to trust them. So yeah, the goals, we focused on 3 goals in the Sapphire program, which were security and more specifically robustness of the AI system to attacks, because yeah, it's a system, it's AI, but that does not mean it can't be attacked like any other system. And there's actually been a lot of work on how to attack the system using adversarial attacks, things to get the data from the training, just from the prediction that it does, and a lot of stuff. Second aspect is explainability. How do we explain the results of our AI? Because that's what we want to bring trust in the AI, that we want to understand the result, to be able to explain it to people that don't understand AI but understand the work behind the physical reality of the problem, for example. And then we also want our AI system to be fair. We don't want red-haired people to be discriminated against because our AI is not fair. So that's the 3 main goals of the program. And then we also don't want to forget to bring some awareness to citizens, because that's also our goal of informing of the threats and what is possible with AI. And lastly, a bit of the legal framework has been introduced, and with ethics concern, like GDPR, how do we work with GDPR in AI? Fun question, but not so easy to answer, because what you do with data in data has been trained and stuff like that. So my goal, and I'll keep the time in mind, is to do short presentation, short demo on the 3 first points of the work we've done in Sparta on that in Sapphire. So first one, I'm gonna talk about the robustness to attack of the models. So what first point you might wonder, and maybe you have had the presentation a lot of times if you went to AI conference and stuff, what is an adversarial attack and how it is perturbating the system. An adversarial attack is often a small perturbation introduced on the input of the system, and just really a small noise that induce a total different classification or result from the AI. So you see from the image, the duck is now a horse. On the right, we see even that it works in physical reality. So you put a small sticker on the stop sign and it goes, it's a speed limit sign now. And that's working. Nobody will say it's an attack when you see a sticker on the stop sign. And so that's imperceptible in our mind, but actually that's an attack. And I wanted to take also the bottom left example because it's actually common now to just put image and say adversarial attack is on image, but sound is working as well. You can do adversarial attack to AI system on sound, and then that makes you think that all the recognition systems, audio recognition system like your Alexa and stuff like that are being, you can just manipulate that with adversarial attacks. We have a nice example at CEA of autonomous vehicle being directed through the radio and adversarial attacks on the radio. So it's not limited to images. And actually the first demo I want to show is on intrusion detection system. So it's a system that detects through AI. So it's an AI system that detects based on network traffic, that detects whether there's an attack on the system, on the server, on whatever. And it says whether there's an attack or whether it's normal traffic. And on that system, we can do adversarial attacks. So the inputs of the AI here is basically traffic on port number 43, things like that, number of bytes sent on here, IP address, stuff like that. So it's purely tabular data, and we can do adversarial attack here to make the AI system misclassify an attack as just a benign, normal traffic. And so here we want, first thing we try to do is a defense against that. So trying to add another layer to the AI system to defend ourselves against such type of attacks. And yeah, if I can have the video with sound.
The procedure starts with training a neural network for intrusion detection.
Okay.
As you can see, the IDS achieves accuracy of over 90% and similarly high precision and recall rates. This means that the IDS can spot almost all the attacks in the dataset. The attacks are samples to craft adversarial attacks. Adversarial attacks will be able to fool the IDS. 4 different attack creation methods are tested to generate adversarial attacks.
Can just cut the sound and I'll just go quickly over it.
These are the features of the attacks before adding.
But because I think it will be clear, I made the introduction a bit short here. But so we are generating attacks here, and you see at the moment the system is classifying everything. So that's the normal setting. Everything's been classified as an attack or benign. There's no problem. Here we are generating new attacks on the system. They look pretty similar to the normal traffic. And then you see the system is classifying more than half of the attack as benign. So it's red on the left, it's benign. On the right, it's benign. So those are attacks, real attacks that have been misclassified by our AI system. Now, that what we will try to do is to take some of the information from the first neural network that detects whether it's an attack or not. We'll take some information and we'll train another system from that to say whether it's an attack, an adversarial attack on top of the attack. Twice the term attack is right. And then, okay, maybe we can cut short because I'm not sure of the time, but okay. So we'll let it play a bit. So it's trained on what we call the neural activation of the first neural network, so it's really if at some point if the inputs are negative or positive, and we train a new network, a new system based on that. So we achieve here, then we achieve on this new, with this new system, we achieve more than 90% accuracy on detecting whether on top of the original attack on the network traffic, we have an attack. And with that, we manage, so 90% manage of the attack, you see here are classified as an adversarial attack on top of the original attack. So that's actually quite good results of detecting whether or not the system has been attacked, the intrusion detection system has been attacked by another attack. Attack everywhere, so it's confusing even me. Just quick show of other example we did in Sapphire. So we did adversarial attacks are working also on breast cancer detection systems. So it's an AI that detects based on a biopsy whether a person has a cancer or not, some kind of cancer, and you can attack that system to make it say there's a cancer where there is not, or the inverse. And we design a few defenses here. We also design defenses on systems like PDF malware, detection of malware in PDF. So AI system that detect malware in PDF, facial re-identification, and graph anomaly detection. But there's a lot of demo that I won't show everything. Quickly on the second aspect that I wanted to mention today is explainability. Because first aspect was security. How do we defend our system? Now we want to explain also our system. Because if we can't, even if we can defend our system against attack, well, it's always better if you know why it took the decision. You can explain it to someone, and at least even if there's an attack that we didn't manage to defend against, you can always look at the explanation and say, yeah, no, it's taking a wrong decision because it's written is doing that, it's bullshit. And so, yeah, most AI systems are black boxes. You don't know what's in that. Well, I know some of them. I don't know everything. And it's hard to explain even if you know what you did in your system. And explain it in understandable terms is even harder. So that's why we want to provide some mechanism to do that and to enhance the possibility, the trust in the system, and a lot of stuff is useful like that. So one of the methods we define here is hybrid oracle explainer. So it's just actually we do a surrogate model on top of the original detection model. So the model is a neural network, same as the previous one, that is just predicting still the same stuff on, still predicting whether there's an attack in the system or not. And now we are adding to that a system that will give an explanation, that will give you why the neural network said it's an attack on that system. So if we pass over the complexity of the stuff, it's just we find the closest explanation in a group of explanation we have and display that. The explanation is on form of a tree, and it shows the different conditions that led to that decision. So parameter 1 was inferior to 0.5, so that leads to that parameter 2 is superior to 2. So that means, okay, and then with a few parameters, if we can put the video, we can draw a pretty nice tree saying, okay, these are the consequences that led to that decision. So that's one of the tools that has been developed by a colleague at ITTI to showcase that that system. So it's a framework that shows the number of attacks, suspected frame, clean frame, so the normal traffic on a network. And you have the typology of attacks on UDP, HTTP, etc. And then if you click, so we click on the traffic frame here, and we say we want to get the explanation. So we have few details of what are the info here, so that's the input. And then we want the tree explanation of why it's an attack. And so that's what we get. So you see on each of the nodes, or well, on each of the branches here, you have the parameters and the value that made it decide. So we see that following the branches, we get the final prediction, and that's with that thought process from the neural network that we decided it was an attack against the system. And then we add on top of that a few other insights. So the insights are on the influence of the different variables. It's just Lime explainer. So it's the influence of each of the inputs on the decision of the model. And afterward, we just take another attack or the traffic info, and we show that the decision process can be totally different. So here we took the attack here, and you see it was not exactly the same thought process here, but we are explaining that in this form of trees. And same, the influence of the input here as well. Sorry. Okay. Thanks. Okay. So that was explainability. So now we can explain our AI system a bit. Not totally. If we could, it's not. There's no use to AI if we could do that. But no, as I said, we don't want our system to be biased to red-hair people because we don't like them. Sorry about red hair. No, it's fine. But you might say, AI, it's just math. It's matricial operation, successive matricial operation. Why? Is it not objective? That's first thought. If you see equation, a mathematical equation, it's objective. It's taking input. No. But yeah, but no. Why? Because we are training our network on data. We are training on some kind of input, and the input might be in that data. If we label ourselves images with information for the AI to train afterwards, if I'm biased against some kind of people, I will put the bias in the data, and then the AI system will train on the bias, and then there will be a bias. Same, if we take data that are not representative, well, the AI will only learn what it's been shown. If we are missing half of the population when taking the data, well, the AI system can't guess the other half of the population. And so what we want to try here with a small demo from Thales is to reduce that bias, to be able to have system that whatever the sensitive attribute we want to protect, we want the system to be fair with regard to that, with regard to age, with regard to skin color, and others. So if we can, let's put the video. Yeah, thanks. Okay, so here, oh, sorry. The use case here is recidivism, sorry, AI that predicts whether some person will do another crime after doing a first one. And it's been seen, there's been an article here on that system that says, well, actually, the AI we train on that database has a bias toward Afro-American male of under 25. In the US, it's in the US, it's easy. And maybe if you can post quickly Okay, thanks. So here you see we display the repartition of the probability of recidivism in function of three categories, three criteria that are sensitive, so gender, age, and race. And you see the probability in orange is a lot higher for male under 25 Afro-Americans. That's what we want to avoid. And if you play it, we see that even removing this attribute, so removing the age from the input, does not work. The system is still biased. Sorry. And so what we want to do is train a system using two networks, one that penalizes the other in function of the sensitive attribute, to learn without taking that too much into account. So here we see at each iteration of the learning, we see that the curves are overlapping more and more, and that the system are getting more and more fair to male under 25 Afro-American. And that's good. We see, if we calculate some fairness factor here, we see that no, it's 95 to 100% fair, or 80% on gender. So it's actually a lot better. It was 50% fair on the beginning. So that's what we want to do here, to learn fair system. So that's one of the use cases we developed in Sapphire. I think we can stop the video here, because afterwards it's just explanation. Okay, thanks. And so that was the third topic of explainability in Sapphire. And I will not go over all the rest of the results of Sapphire, because I think did not check that much the time, but I think I'm okay. And then just a few other points. So on awareness and legal issues that I mentioned in the beginning, we did some work as well. Interesting work on doing a threat database for people to look at what are the possible threats on AI systems. So it's like, you see MISP for AI now. That's more or less what we did here for threat intelligence in AI. We did a Sapphire, sorry. We did an AI contest to raise a bit of awareness among people of, well, the threats and the attacks possible and the defense possible on networks. So as I said, we studied the implication of GDPR to AI system, and we also did some consideration on the Artificial Intelligence Act. So that's also plenty of more work here that I can't detail too much today, but you can go to SPARTA website we have made by myself. There's plenty of explanation here in the deliverables and in different articles we published here. Yeah. That's it for me. And yeah, so.
So do we have any questions?
Oh yeah, question.
Any questions for Augustin? Yeah.
Hello, Carlos from the University of Trento. Thanks for a very interesting presentation. You were mentioning the use of neural networks, so essentially machine learning, and you addressed a lot about explainability, which is one of the main concerns, so that's, I think that's great, that's really put in the foreground. You also mentioned a 90% accuracy, which raises the question to me, how do you know, or what measures were taken to avoid overfitting in terms of cancer, for instance, to avoid false negatives?
In that one, sorry, I don't know here if there's... well, actually, well, except on classical separation of the trained test and validation sets, I'm not sure if there's been more measure, but I guess the ITTI guide that developed that are quite used to that. So I hope they took measures into account to avoid overfitting, but I can't detail them. Sorry. But that's not my work, so I can't say.
Any other questions for Augustin? Yep.
Thank you. Benedict from Siemens. One question I have regarding the breast cancer research you did. What sort of data did you take as input? I think you mentioned biopsy data, right?
Yeah, the small images that were taken, that were on the slides, are the small pictures of the biopsy tissues of patients. Yeah.
Do you know where the source of the data was?
It's from some, it's on a Kaggle dataset. So it's a public dataset online done. I can't remember like that the hospital and the university that made that, but it's a public dataset on breast cancer. You should find it on Kaggle if you want.
Thank you.
Any other questions? Yep.
My side for the next presentation. I would have one question on the explainable AI. So who is the explanation for, who is the target? As far as I see, you use some techie words in the explanation. So do you also plan to work more on making it easily understandable for users?
So I guess the user here would be someone that still knows a bit the ins and the outs, because the explanation we provide is based on the inputs of the system, and we say if the HTTP number of bytes here is superior to that. So that would be security expert of traffic security, of network server security, without knowledge of the AI. The person that manages your server, for example, does not have the knowledge of the AI system, but he has the knowledge of the problem behind that. So we are explaining with the trees, we are explaining in terms of the knowledge of the traffic. And so that is quite enough for a security operator to have his own insight on that. Yeah, okay, the number of bytes is quite high for that request, so that's understandable. So it's for really the security operator here, so the guy that has some knowledge of the topic without having the knowledge of the AI. And that's why you saw it's quite a dashboard developed by ITTI. It's really, it's not like command line, because we don't want to show something really rough like that. So it's made a bit pretty, and then some of the explanation might be rough, but I guess they should be understandable by a security expert.
If you allow me one more question on the fairness. If I understood the explanation correctly, you attributed to issues on fairness to representation or misrepresentation in the data set, right? Wouldn't there be also issues of fairness in system design, not only in the data, but also in design?
In the design of the model itself? Well, I'm not sure that that's... The model is actually quite simple. I'm not sure how you can introduce a fairness issue in there, but then it learns on data, so that my opinion would be the most important point. No, I'm not sure. Don't think so. Sorry. Don't think you can introduce a fairness issue by designing a system in a specific way. Oh, well, if you... It
can be not like... So the design issue could be inadvertent, not deliberate unfair design, but...
Yeah, I guess if the design is really strange and like you take separately some argument and you say, okay, on the gender, I learn it separately from another pipeline and then get it back. But on normal design of AI system, you take every input as they are and you don't even care about what it is. But if people are trying to do some more complex design, I guess you can introduce fairness, unfairness by doing strange stuff like taking apart the gender and then trying to learn it separately or stuff like that. You can do unfair design, but I guess you would need to want it, like to do it. It's not inadvertent, I would say. It's a bit hard to do. I don't see how you can do it inadvertently. I guess you would need to be unfair yourself to design an unfair system.
Well, if you start designing very complex pipelines and very complex aggregations and so on, it might be that somewhere inadvertently there is some sort of a bias that you introduce. You never know.
Yeah.
But piggybacking on that, in software engineering, we have since the 80s, we had the cascade model, and it went on. We have hundreds of software engineering methodologies that are best practices. In the case of designing an AI system and developing, do we have a best practice methodology that assures fairness and so forth?
No.
Exactly. Have you been working on that or looking at that?
We've been trying, at least in the project, to organize a bit ourselves on such practice, and that's also a bit of the work we've done on awareness, on doing a contest to show what could be the bias and what could be the issues. But it's true that there's
something we really need.
It's really needed, and there's a lot of best practice that are not there, and very easy best practice, and yeah, it's still to come.
But when you talked about explainability, it's about explaining individual decisions. Have you also looked at, because you can, when you explain individual decisions, you can sample the system and check that these decisions make sense. But when you want to certify or verify compliance, it's a whole different ballgame, of course.
So it's not part of SPARTA. It was not designed that way, but actually that's my area of work. On safety of AI systems at CA, we are working on trying to prove formally a certain kind of properties on this system. So, like, prove that in that kind of situation, the AI will never go right into the wall, and stuff like that. And yeah, that's why also I mentioned robustness, and I quite like the term robustness to attack, because it's not perfect defense to attack, because we are always targeting specific points. We are always saying the attack on that image, the attack on that data set, but we trained on the data set, we defended with that data set in mind, but we take another input. It's not known by the AI system. What do we do with that? It's messing everything. And that's why we are more robust, but we are not imagining a perfect defense. And one of the aspects and one of the answers that we can bring in is formal method and proving global safety properties on system.
Okay, thank you very much. I assume there are no other questions, and well, we have to continue with the next one. So again, thank you very much. That deserves more than a lot of So last but not least for this session, we have Peter Hagstrom from ECHO, who will present what was done, or part of what was done in ECHO. Please join me. It's always nice to have Peter on a call, because you know when Peter says something, it is a solid engineering answer. It's no vague answer that you don't know what to do with. So I've learned to rely and trust everything that Peter says in the call. So I'm very, very happy to be able to present you Peter, who will be presenting the results from ECHO. Go ahead, floor is yours.
Thank you, Wim. So I am Peter. I work for ARIA as an R&D manager. For my background at ARIA is basically I've been working mostly with software development and leading software teams. For ECHO, I've been heavily involved with the EWS system in work package 5. Is it this one for changing the slides? Thank you. So the background to the ECHO project is really that we began looking at different gaps. We saw that there was a lack of effective assessment, risk assessment over multiple sectors. Normally, risk assessments goes to very, very depth into specific sectors. but there was nothing where we could analyze multiple sectors together. Analyzing them, and I think Wim touched on this yesterday in his presentation, basically leads to us undiscovering different dependencies between different sectors, but it also acts as a catalyst for identifying different needs. So we used it to develop different roadmaps and to invest in the different technologies that we have built as part of ECHO. The ECHO consortium is coordinated by Royal Military Academy, by Wim, our moderator. For the project management, RIA is taking the lead on that, with Matteo Marialdi in front seat. One important thing here is to say that we started around 30 consortium members, but during the project we have managed to reach, I think, 45 by now, which must be seen as a win for us. We have a couple of main concepts that builds the ECHO consortium. As you can see, these are the different assets that we have developed as part of ECHO. I would like to touch on the first one, the governance model, a bit more, because the idea was really to form a guidance to how a research network could operate together. It's a full governance model for that, but also to enable the organizations that wants to continue ECHO outside of the project scope to have a guidance on how they can act together. The reason why I wanted to touch a bit more on that is because the others will be more covered in the slides that will come. The ECHO Multi-Assessment Framework, or EMF, is really the foundation to all our work. And I think this is a bit reiterating the message from Wim from yesterday, but you might confirm that or not, because I wasn't here. The idea is basically that providing this risk assessment over multiple sectors, we are enabling the different things we want to do in ECHO. So you can see that this is working. We used it to basically derive our technology roadmaps, to have a risk-based methodology to analyze different sectors and their needs, and to identify the technology roadmaps and the technology innovations that we are building in ECHO and development. The real outcome from the EMF is 2 prototypes. One is an Excel that we can be using as a tool for performing the risk assessment, and the other one is a software tool that aids the same process. As you can see, it basically enhances the risk calculation. We have the possibility to assess multiple sectors and derive the more complex scenarios using this. So it's very fundamental to the work that we have been doing in ECHO. One of the things developed was the cyber skill and training curricula. The idea is that we wanted to have a method to basically derive new training curricula. By basically taking a lot of input also from the EMF, we have basically created a tool which allows you to take input on your user needs and then provide a tailored training to be used by different institutions. It has been fully developed and already delivered to 2 schools during 21-22, involving 80 different students. And we have been developing training curricula for the different areas as let's see. So the training curricula for maritime sector, for healthcare sector, and for transversal. And then we have mostly done it also for energy sector, I think, but it's something left for the energy sector. Looking at another asset we have developed in the scope of ECHO is the cybersecurity certification scheme. The concept around the cybersecurity certification scheme is really that we looked at EU and we found that there is no certification scheme for products. There are specific sector-specific certification schemes, but they are not looking at it on the product level. So what we wanted to do was to create this product-oriented scheme that allowed us to basically use one certification scheme over the different sectors and to apply on different products. The scheme is already completed and has been used and tried on our cyber ranges, where we have studied it using different security targets and security profiles. The certification scheme is already actually being exploited commercially. So we are using it from RIA's side in a project around drone certification where nothing prior really exists. So it's very exciting for us to already take the results from ECHO and put it into use into the market. The technology roadmaps. From the grant agreement, we had a mandate to create 6 different roadmaps, 2 of which is the early warning system and the federated cyber range, and then 2 additional technology prototypes that we were to develop, and 2 future innovation roadmaps that basically were things that we didn't develop but was supposed to come later. During ECHO, we actually managed to deliver 14 different prototypes that we have been building in the scope of ECHO. And I think José will give a presentation more in depth on the different prototypes a bit later today. So as I said in the beginning, EWS is really my little child. So this is where I spent most of my time. The idea with EWS was to build a tool that could allow multiple organizations to coordinate response to incidents, to share information and knowledge among them among the members of the federation. Also to exchange warnings about events that they might see or experience on their side. And the idea is to provide situational awareness and a better security posture for the individuals that are part of the network. While being a very secure system, of course, which allows the members to exchange just information that should be sent to the other members, and with the different CIA principles being respected. We're trying to answer in multiple different, let's say, dimensions with the EWS. So we're both trying to provide strategic intelligence, tactical and operational, as well as more technical data. The idea is that we can build a federation of different nodes, but we can also create different groupings over the members that belong to this federation, allowing organizations to trust each other and exchange data in these trust boundaries. One important concept was that we developed EWS as a core system with the idea to be extendable by different prototypes, and I think that's one of the factors why we have managed to develop so many prototypes, because as you will see during the presentation, everything ties into each other, coming from the EMF, going through the technology roadmaps, and towards the demonstration cases. So you can see 2 examples of plugins that are integrated with the EWS on the right here. As I touched on before, we wanted to have a secure mechanism to exchange data between different members. So what we allowed AWS to do was to split each node instance into multiple tenants. So it's a multi-tenant system, but it's not enough to just be multi-tenant, because for some organizations it's very, very important that incident information, for instance, is not being transmitted outside of your own organization. You would like to keep this information to yourself. So we created the federation mechanism, which allows DWS to communicate over a messaging protocol that we have developed, which in turn leaves the system being eventually consistent, partition tolerant, and ensuring high security over bidirectional TLS channels. The development is complete. We have currently deployed several nodes across the consortium members. And we have been using it in 7 different tabletops, where we basically have long-running tabletops simulating different events on critical infrastructure and things like that. It's currently ongoing in the validation phase, so we are quite nearly done with everything for AWS. Now there's a
we live in
video,
a connected world,
just a
with our
presentation
businesses
of the
and
AWS
critical
tool.
infrastructures
I think
online.
there's some audio to this
Every
one
day
as
we
well.
depend on the coordinated security, reliability and resilience efforts of IT operations across entire sectors. With the increasing sophistication of cybersecurity threats and the expansion of the cybersecurity attack surface, the need for secure exchange of information is not only important, but crucial. The early warning system developed by the ECHO Consortium is a product created for the European digital market to address the need for safe cybersecurity information exchange and early warning coordination and sharing. With the early warning system, we aim to provide an opportunity for public and private organizations across Europe to upgrade their existing cybersecurity practices and become a part of a collaborative and resilient ecosystem. The ECHO Early Warning System is a fully customizable product through which you can implement your internal incident response, optimize the workflow of your incident response teams, collect and analyze threat intelligence information tailored for your sector, and share knowledge and warnings both internally in your organization as well as externally by sharing anonymized data to help other businesses in Europe take proactive and timely measures against cybersecurity threats, vulnerabilities and incidents. The ECHO Early Warning System operates in a multi-tenant mode, allowing multiple organizations to belong to a shared tenant or to host a dedicated cluster node, providing them the opportunity to create their own instance. The level of information sharing is fully customizable and under your control. To extend the capabilities of the ECHO Early Warning System and make it adaptable to the needs of the different members of the ECHO network, we have added a set of functionalities that you can choose to subscribe to. Those additional functionalities are granted by an ecosystem of plugins that enable you, for instance, to collect unstructured text data from social media, as well as interfaces to extend your vulnerability scanners, automated correlation models to compare information from multiple TISPs, threat maps, and many more. The ECHO Early Warning System is built with flexibility and adaptability in mind. Its design encourages integrations, such as cybersecurity incidents coming from internal or external ticketing systems. This external data can then be monitored from visualizations provided by the ECHO Early Warning System through a dedicated interface, which allows you to connect your external monitoring solutions and perform queries over data from both your system and the ECHO Early Warning System. This way you can combine your cybersecurity solutions into one system and extend the functionality of your existing solutions while providing you with additional opportunities to share and receive anonymized cybersecurity intelligence within the ECHO network. Last but not least, the ECHO Early Warning System provides you with sophisticated, yet easy to use and customize, data visualizations and statistics through a set of dashboards and user views. This way, you have an at-a-glance understanding of what is important for you and your business, and you have all the benefits from the access to not only attack information, but also crafted analysis and intelligence items by the eco-analysts and experts. Our mission is to support organizations in their cybersecurity operations, putting innovation, excellence and people at the center of the European cybersecurity effort, and provide mechanisms to enhance the collaborative cybersecurity capabilities in Europe. If you would like to learn more about how to use the Eco Rewarning system or any of the other Eco products, or if you would like to join the Eco Network and receive a dedicated demonstration, contact us at econetwork.eu. Thank you.
So that was a short introduction to EWS, showing basically the capabilities and the tool that we have built. Moving on to the EFCR, which is the Federated Cyber Range. The idea with the cyber ranges are, as you know, to create scenarios and make a replication of something, a real IT system. What we saw was that we could create there are specific ranges for sectors. We could have specific capabilities for maritime, for space, and so forth. But it's very hard to combine these different capabilities. And with the cyber ranges, we wanted to give that capability to basically combine different cyber ranges capabilities and offer them as a commodity to whoever needed it. The cyber range is, of course, also very important for our internal activities. So for our R&D testing, our demonstration and technology roadmaps and everything is basically using the federated cyber range to demonstrate the operation of it and to create relevant scenarios that we then can simulate. We really had two goals with the EFCR. One was to create the interconnection between the different cyber ranges. The other one was to offer a marketplace where anyone could go in and basically pick and choose what capabilities they need for the scenario they are running. Again, the development has been completed. We have currently integrated 9 different cyber ranges, and the marketplace is also they are also integrated to the marketplace. Technology-wise, it's basically building overlay networks over these different ranges and providing them as just one single experience to the end user. Then there are a couple of intersector prototype tools or prototypes. I know that José will go into more depth about them, so I would just like to touch and reiterate the numbers. You can see here we have 14 innovative solutions that we have developed as part of our technology roadmaps. And the rest I leave to José to go more into depth about. We are aiming for quite high TRL for most of our prototypes. Some are 8 and some are 9, I think. We needed to come up with a way to basically demonstrate how this works and prove our high TRL. So the concept we developed was the one of demonstration cases. What it is really a problem that is solved by a combination of different eco assets. But they are agnostic to sector. So you can see all the critical sectors that we have identified are basically applicable to these different demonstration cases. What we did was to develop 5 different, but in reality I think there are 2 more, where we have the different issues on this axis, and then we can see the combination of tools here. For the eco early warning systems, you can see we have 2 specific demonstration cases. What we've been doing here is to use the EWS for the tabletops and to demonstrate it in such way. For the other, we have built specific demonstration scenarios. So the difference between the scenario and the demonstration case is basically that now we are sector specific. So for the energy sector, we created a scenario, again on the federated cyber range, where we had a control and command system, and then we offered training as per the previous slide, where you could see the horizontal with the tools that we developed for the training. In healthcare, once again, you can see the cyber range being used to demonstrate this. We focused on the training aspects, so connecting back to the training asset, but also on the certification scheme. So by using this scenario, we managed to basically build a corporate hospital IT system and analyze an analysis lab. And then we had several things that we used this for basically showing the demonstration scenario. And then we developed one for maritime as well. So for maritime, we once again focused on training certification. So for this, I think we are simulating a ship where there is some kind of attack on the GPS link, and then we can see the different things playing out. These demonstrations, scenarios and cases are really coming from the EMF and how we derive the different risk and the needs. So you can see the link basically between the demonstration cases going all the way back to the first asset that I presented. You can see that we're combining a lot of different assets to basically cover as much ground as possible with Echo. And you can see basically the tools being integrated and used. So the EFCR being the technical solution where we can run all these demonstration cases. The EMF providing input to basically all activities that we have been doing. And the EWS running as a parallel for the situational awareness and information exchange. Finally, we are very active on social media and are available on all these links. So please go in and follow us if you have the possibility. If you are interested in hearing more, don't hesitate sending us an email, and we will definitely come back. Thank you for your attention.
So do we have any questions for Peter from the audience? We have a few minutes. Yeah. Antonio.
Thanks for the nice presentation. I mean, I have a question regarding, because the other scenarios that you present, one of them that was not very clear for me, how you make the connection, I would say, between the AWS and the certification schema, basically, because you already mentioned that you already have a concrete approach to the certification schema based on some scenarios, I would say, that's my understanding. Mm-hmm. So can you explain a little bit more how this have been done? How is it?
So for the certification and the early warning system, we have not really been using the certification scheme to certify the EWS system. So they are not really touching each other so much. But we have been using similar prototypes as a security target on the cyber range to basically have demonstration of the certification scheme, not of the prototype. If you.
Regarding the certification scheme, just a small additional thing. You already mentioned that already you are validating this for the European certification scheme approach in that sense. Are you? What is exactly the process you are following there?
I'm sorry, I cannot really go into detail. I'm more on the technical EWS side. Maybe Wim has some more actually.
In any case, because I mean, we have in cybersecurity, Cybersecurity for Europe also one scenario that's similar to the one that we have there. So it would be good to check
yeah,
basically.
We can match them and to people. So basically what we have been doing is using a few of the prototypes that we have developed and then trying some sort of a test certification by writing a security target for that specific prototype that we built. And so that's where we applied our, like we said, we had specific assets and threats for the sector, and then we checked to what extent that worked for that specific prototype that we developed. So that was sort of a test run for certification. And more will follow. Voilà. Do we have any other questions or comments? Because, yeah.
Okay, thank you for the presentation. I have a question for the EWS system. So you have developed all these platforms from scratch, or you relied on some existing technology?
So the EWS is it's based on an early development that we had at RIA, which in turn is also based on knowledge coming from an even older project that we developed specifically for the military sector. So we cannot really use that for this, but we have developed a similar capability before going into ECHO that we have been building on.
Then another question. I saw that your affiliates also have access to indicators coming from external sources, not only from the incident response teams. So do you also provide some mechanism for the validation of these indicators and for their prioritization?
We have a prototype, if I'm not wrong, that works specifically on trust matrix over different identifier compromise, malware information that has been shared, etc. But unfortunately, I don't have the details really over how the trust matrix works.
And is it then an open framework, so other partners from the 4 pilots can join? Or which are the conditions then?
Yeah, well, actually, I cannot respond to that question, but...
Yeah, just like every pilot, we have different levels of joining the project, going from very loose coupling and just participating in, or getting information, then you can participate in tabletop exercises, and it can go all the way into working on the So if you're interested, do contact us and we'll get together.
Thank you very much.
Yeah, absolutely. Voilà. We have 2 minutes left before the coffee break, so for a quick one? No? Well then, Peter, thanks again. I saw that... sorry, there's a question. Yeah, a quick one.
Is this called open source for the EWS?
No, it's not open source for the EWS.
Yeah. So I saw that Catherine Zeta-Jones was still very active in producing incident response tickets in the EWS on the video.
Indeed.
So it was good to see that she's still alive.
She's here.
Perfect. Thank you very much for your presentation, and thanks again to the other presenters as well. So now we have a coffee break until 11:15, and then we will continue with the next section on the verticals. See you there and then. Thanks.
Thank you.
Okay, so I think we have almost everybody back in the room, which is nice. That means that we can start with the next session, which will be on the verticals, where the different pilots will be presenting how they address the different verticals, how they looked at it, and which ones that they address. So it promises to be a very interesting session. And I suggest that without further ado that we start with the first presentation by Alessandro and Christos from CyberSec for Europe. I think Alessandro is going to give an introduction and then Christos is going to take over from there. So here we go, the floor is yours.
Thank you. All right, good morning everybody. I'm Alessandro, the work package leader of work package 5 or CyberSec for Europe, which is responsible for the implementation and design of the demonstration cases. And, oops, this is the wrong button. That's the right button. The goal of our work package is to identify and analyze cybersecurity challenges in our project verticals and to translate those challenges into tangible demonstrators. And in the process, we also collaborate with Work Package 3, which is the research work package, which this morning Antonio introduced, and Work Package 4, which is the roadmap, which I believe today they will talk about. This is the modus operandi of our project. It was organized in 2 cycles. Work Package 5 is right there in the middle, and the way this works is that we had 2 cycles of design and development, and in the first cycle we defined a first, I would say, very alpha version of the demonstrators, where we also identified the requirements, and we gave these requirements to Work Package 3 so that they could take our needs into account for their research. And in the second cycle, we took into account the feedback and all the lessons learned from the first cycle, and we integrated them in the next version of our demonstrators. And these are all the verticals that we take into account in our project. I have put there all the names and contact of the task leaders of this these tasks. And if anything is of interest to you, of the things I will say today, I encourage you to contact these people. So our verticals are the open banking and the supply chain security, privacy preserving, identity management, incident reporting for the financial sector, maritime transport, smart cities, and medical data exchange. And I will now briefly go over all of them. Unfortunately, we don't have enough time for me to go into the details, but I will give you a brief overview of what each of these tasks is about. And the first one is open banking. Open banking is a task which is responsible for finding some new innovation in the security issues of banks, in particular interest or attention to regulations such as PSD2 and GDPR. One of their demonstrators it's called Obsidian, which is about fighting fraud in banks. And banks, they are very sensitive to their data. They don't share that much data within themselves. And Obsidian wants to have a network where this is made possible easily by, for example, sharing IBANs of accounts flagged as fraudulent, for example. And of course, they will all be pseudonymized to do that. Our second task is supply chain security assurance. The supply chain security assurance task is about securing the workflow of a supply chain so that it's also compliant to, for example, policies published by supervising authority notification bodies, and also have a look at our dispute resolution in the supply chain, which is a problem of supply chain, and it costs a lot of money and time. We now have privacy-preserving identity management, and in this case, the task wants to implement, let's say, a portal where users can decide what information they will want to disclose or use for particular profiles for different uses, and they will have a concrete prototype in a job portal, a job application process, because there's been a problem with people applying for jobs with fake qualifications, for example, fake degrees, and they want to have a portal when all these things will be certified anonymously, for example, and users can decide what parts of their history of qualification they want to use for that particular identity, for that particular job. We then have the incident reporting in the financial sector. Incident reporting in this case means security incidents. And I think it was also discussed a bit yesterday, the fact that organizations don't really share information about their security holes or security incidents within each other. And this task want to, let's say, address this problem by, of course, also be sure that it's made in compliance with supervising authorities, but so that various organizations can share data about security incidents within each other, and also all the data that they gathered while analyzing the security threats and incidents that they just faced. The medical data exchange, as the name says, want to securely share medical data, which is, for example, might sound strange. Why would you want to share your medical data? But for example, in Germany, if you go to a specialist doctor, the results of your visit will be shared out by that doctor to your family doctor. So that's a kind of data exchange. This task also worked with healthcare providers that dealt with the COVID-19 pandemic in the past 2 years. So in their platform, they try to give some kind of flavor with COVID-19 data and dealing with COVID-19 data, the sharing of this data in a secure and private manner. And we also have the smart cities scenario, and as you probably all know, smart cities is all about giving new services to users, to citizens in particular, and they, in this case, the tasks want to have to give services to users that allow the users to decide what kind of personal data they are willing to put into the system to receive that service in exchange. And as a consequence of this, the local administrations will have an easy system to identify risks in their, for their infrastructure, and also an easy way to address them and implement new services for the users. And they are currently working with 3 administrations: Murcia in Spain, Genova in Italy, and Porto in Portugal. And I skipped the maritime transport task because the maritime transport will now come up here and show in detail their task. We thought that would be nice to actually show you some of our works in action. And given the time, we could only choose one, which was the maritime transport, because we're not only it's a good representation of the research we did in Work Package 3, which Antonio again showed this morning, but also because the maritime transport is not something that we think about that much, but most of the things you own and most of the things you eat are actually transported by ships. And if you look at the war in Ukraine, you see right now that you have a food crisis because the wheat from Ukraine cannot be transported outside the sea with the ships. And so, of course, ships have a communication system, and as we all know, where there is a communication system, there is a risk for attack by a malicious entity. And so the maritime transport is all about this, addressing cybersecurity risks and challenges in the maritime transport settings. So Christos will come up right now and show you everything you need.
Hello, everyone, and thank you, Alessandro. Don't have the presentation yet. Okay. For the next slide. Okay. So, as my colleague mentioned, the maritime transport is a very complex field, and it actually engages any structure, mode of transportation, and equipment required for the carriage of passengers and goods via the sea. All the supply chains that work in nowadays they're supported by maritime transport. So it's the driving force of international trade and the backbone of globalization. Can we? Yes. The first thing we did in the maritime transport vertical was to identify a set of critical services, let's say, that needed to be protected, the critical services that are required to put through all those goods, all those passengers from point A to point B. So, some of those critical services might be ship accommodation, it can be management of water transport infrastructure, passenger transport, route planning, ship maintenance, and any of those, and many more services. So those services can be tied very strongly with a set of known threats that can happen throughout the seas. So some known threats in the cyber field at least are GPS spoofing, unauthorized access to onboard mobile devices, like this example, unauthorized access to onboard mobile devices. Some external actor might gain access and access the ship systems, maybe redirect the route, maybe inject something in the information that it's getting from the vessel traffic services. There are a lot of attacks nowadays, and we've even seen some tech-savvy pirates attack Verizon servers, gaining access to ship routes and the container layout, going up on a dead zone at night on the ship, and then looting everything they wanted without anyone taking notice. So these are new threats that we haven't seen and that we need to deal with. So, in this context, as you can see in this picture, we have all of the interconnections between different vendors, different services, and the goals we set to protect this infrastructure is to manage security threats and risks, harden the security of the involved systems, and secure the communications between the various maritime systems. To achieve this, we developed 4 use cases. Those use cases include threat modeling and risk analysis for maritime transport services, in which we essentially map the inventories of various maritime transport processes and services, and then we go on to tie those assets to specific threats, vulnerabilities, and produce some risk results for all of these systems. Then we move on to the maritime system software hardening, which we can use to harden systems that are utilized throughout communications, to even harden the tool used for risk assessment, for example, because this is also a point of attack, if you think about it, because all of your asset inventories are there, and if an attacker had access there, this would be a great issue. Then we move on to the secure maritime communications, where we have developed a video system, and finally we have the trust infrastructure for secure maritime communication, which entails the functionalities related with the design of a trust infrastructure, in this case a public key infrastructure. Can we play the demo? We will move on to this video. We have 2 demos here. This is an introduction that shows the field and how attacks can happen throughout this field. And we will move on to the risk assessment tool. So, as I said before, here we are able to map specific assets, and this is strongly tied to open source data because it utilizes the common platform enumeration catalog, which, as you can see, contains known assets from Microsoft, from Amazon, from any known vendor. It has over 1 million entries, I think, right now. And we have some visualizations related to the connections of those assets. And then we can connect those assets to specific vulnerabilities derived from the National Vulnerability Database. And further entities like CWE, and right now we're extending it to include CAPEC and the attack framework. So, all of these assets and vulnerabilities need to be put into a context of services. So in the maritime field, we have multiple vendors which trade assets and have assets that communicate and work together. So we need to set services in which the different asset maps of different partners communicate and they work together, and finally they have attack paths going from one vendor to another vendor. These are some of the results in diagrams, and finally we will see in the video the attack path generation after this. These are some scenarios and how we calculate the risks for each asset. And finally, if we set some entry points and some target points for the asset maps of specific services, we can produce the attack paths. So this is the example. We include some entry points that we would like to see as entry points of an attack, and then we see some critical assets as the target points. And all of the paths throughout connected assets are created from entry points to the other points, to the target points. And then we have the maritime PKI demo as well, where the operator can request a certificate and produce this certificate in order to enable VDES communications further and to secure VDES communications further in our case, which we will see in a bit. So this is a simple process. You just apply for a certificate, and then you can see that the certificate is created. And you can see all the information over here. So we move on. Sorry. Okay. So we move on to the secure maritime communications. So currently there is no cryptographic authentication authorization or integrity measures in place for the maritime communications. And the automatic identification systems, AIS, do not easily allow for cryptography due to the size of the messages that you can send throughout AIS. So VDES is a new standard which can accommodate crypto and which can hold messages bigger in size, so that we can include the encryption actually, because the encryption makes the size bigger by including salts, by including many techniques. So we have implemented a VDES-ready communication prototype that can connect to the PKI I showed you before to request a certificate, and then we can allow for cryptographically secure communications to exist. So our prototype, in this case, uses privacy and security by design. We use privacy-enhancing business process model notation with visibility tables, along with visibility tables and leakage analysis. And finally, some white box penetration testing. This is the schema of the prototype, and this is the schema of the prototype. And these are the generated visibility tables, as I told you, and the leakage analysis. So, for example, here, if we have a set of data here, we can do the leakage analysis and see if the data, see if the leakage is conditional, where we would see an if the data would never be leaked, where it's never, and if the data is always going to be leaked, we're on red. In order to further secure those processes, we also did the hardening of maritime systems. So throughout hardening, we saw that maritime systems utilize native components that are known, that have very known bugs, like the OpenSSL that I'm going to show you in a bit has the heartbleed bug. And those are written in C and C++, and thus suffer for various memory corruption vulnerabilities. These vulnerabilities, if they're successfully exploited, they can lead to severe consequences that threaten vessels' normal operations. So, for example, if the message is not encrypted properly, or if the OpenSSL that transmits the message is not applied properly, we can have an actor in between the messages that can intercept and that can inject things. So the message either doesn't reach the destination, or it reaches the destination with further information that wasn't initially meant to. So, in this case, we're going to showcase the control flow integrity implementation. So, control flow hijacking attacks exploit memory corruption vulnerabilities to divert program execution from the intended control flow. Oh, so I'm going to move faster. Sorry. So, this means that maybe from, in this case, we did the we rerun the OpenSSL with CFI. And what we do is move from a main function without showing the code to the machine to the hardened function. So anybody executing this wouldn't be able to see the initial function. Finally, we have some research output. We had a lot of research output, actually, in this task, where we utilized our previous methodologies in risk assessment and combined them with the hamsters tool in modeling human tasks to enhance threat identification in critical maritime systems, which was very interesting to see an approach where we further describe actors. And we also did an adaptive situation-based risk assessment and security enforcement framework, where we also connected with another tool called DINSMOG from UPS IRIT. And finally, we created our own cybersecurity ontology to support risk information gathering in cyber-physical systems, where we created our own graph database, which we're not going to see the entire video right now because we don't have time. But essentially, we created a local database that takes the national vulnerability database and threat catalogs such as CAPEX, CWE, ATT&CK, and connects all those in a local instance that can support our own risk assessment tool when needed. If our time is... yeah. Okay, we can play the video then and see a bit of the ontology and the...
Since December 2021, all MISP users have access to the Concordia framework with its dedicated Galaxy N object. When we now add an event on MISP as part of an attack, we are able to select the Concordia framework as part of one of the...
Yeah, it's a YouTube link in the presentation. I don't know why it didn't work. But essentially, we have localized various vulnerability databases and threat catalogs, and we use them to enforce further data on a risk assessment. Thank you. Sorry for taking more time than... Thank you.
Thank you for a very interesting presentation. We have time for one question. Anybody wants to ask a question? No. Nobody? I have one question. You talked about AIS, and then you talked about privacy preserving and confidentiality. Isn't AIS, by definition, from what I remember, an old VHF-based protocol where ships announce their presence to the world, so it's not required to be confidential, on the contrary?
Yeah, but nowadays this is becoming an issue.
Okay.
Because further entities can get in there, like pirates can broadcast their own signals, and they can mess with the port services, and the AIS doesn't work anymore.
No, but that's an integrity and authenticity problem mainly, yeah? Well, we'll talk later about that. Is there any other question? No? Then thank you very much again for your presentation.
Thank you.
So, next presentation will be given by a team of 3 people from Concordia, and Thanh will start, so I'll let him introduce himself and the team.
Right. First, I would like to thank the organizer to allow us to be present here and at this very, very interesting and really good event. My name is Thanh. I am a fellow researcher at Telenor, which is a Nordic operator. And in my team, I have Bernado Santos from the Oslo Metropolitan University and Madalina from Telecom Italy. So today we are going to present, talk a little bit about the pilot of CONCORDIA. And okay, if we look at the CONCORDIA service board, then CONCORDIA has many facets. We have to connect, we have to explore, educate, and you know, we today now we are focusing on develop, and we are talking about industry application. We have in CONCORDIA two types of pilots. The first one is the one for each vertical industry. And then we have also the cross one, the cross-sectoral, and it's organized in two different work packages. But today we present only the one for the vertical. So we focus on 5 industrial fields. The first one is telecom. The second one is finance and insurance. The third one is e-mobility, e-charging. The fourth one is e-health. And the fifth one is about vehicular communication system. Vehicular here, we are talking also about aerial vehicular object, you know, as well. So this is the 5 focuses that we have in CONCORDIA. But today, because of time limits, we focus on the telecom. And if there is more time, then I will briefly walk you through the other vertical. But we just go in depth for the telecom. So I would now introduce Bernado first. You go ahead and present what we did in the telecom sector.
Okay. So hello everyone, my name is Bernardo Santos from Oslo Metropolitan University. I'm going to present the mobile threat modeling framework that we did for CONCORDIA. So considering the main objective that we have from the telco pilot, we want to enhance threat intelligence platform. And it's divided in 3 use cases, but we want to focus on the on how this can be achieved from a telco, from a network operator perspective. If we focus on the threats that we can see on the 5G, and I'm just going to go briefly to them, we can see that, for instance, we cannot think for a mobile device, we can no longer think as a smartphone. We need to also think as IoT devices and other types of devices. We also may face some new problems in the SIM card because although it's a temper resistant module, it may be exposed to other vulnerabilities. And also, as we consider an application, although you may have some downloads from trustworthy sources, you still may have some data exposures that you are not accounting for, and that could be an issue. And then also from the network side, you may also have some sort of exposure that could be the target for a potential attacker. If we focus on the matter in hand, threat modeling, we want to be able to identify and understanding these types of attacks in order to be able to translate this to platforms to provide risk analysis and furthermore detection methods. We have a attack-centric approach, meaning that we focus on the attacks themselves, but also what the attackers do. And we study those behaviors behind that. So moving on, we have the MITRE attack as the baseline for threat modeling in an attack-centric way. But we need to focus more given the 5G networks, because MITRE attack and its frameworks, and if we focus on enterprise and mobile, they are not considering 5G networks. They are exposed to more than just a simple enterprise network, especially because of the connections that they will have, considering the IoT devices that will become a major objective in those networks. To that end, we have developed the mobile threat modeling framework for Concordia. So basically, it's an extension and combination of matrices as well as some Concordia-own techniques. You'll see that you have the mobile, the MITRE mobile represented in purple boxes combined with the enterprise in yellow. And then you'll have the Concordia techniques owned Concordia in the blue boxes. One key aspect that I would like to show, or actually some key aspects from this framework, is like MITRE attack, it is composed by tactics and techniques, but the innovation here is that no tactic is unique. We consider and document an attack by phases. Also, the attacks documented with this framework can be recursive, so we introduced the concept of loops to showcase this behavior. And also, this is an interesting perspective that we don't see that often, is that the Concordia framework allows you to have an attack documented not only from the device perspective, but also from the network perspective. So you see the joint interaction in these fields. I'm going to quickly present a use case, which is flood attacks for IoT devices. The idea here, basically, is we have what we consider the device stage, which is documented by 12 phases. And you will see that you may have the same tactic represented more than once. And the recursive here, you can see the loop here, basically, because this device stage will happen in more than one device. So once you actually have a lot of devices that have been infected, only then you will have the network stage. That is basically, they will deploy the attack towards the network. Sorry for the very brief introduction on this. I will now ask to play the video. Since this framework is now implemented on MISP. Everyone that has access to the platform can use our framework. The idea is we have a meta object and a galaxy. The meta object will be the important link to showcase this loop and recursive behavior.
Being able to add as many techniques as needed.
You have some subtitles.
With the aggregated object, we are able to establish a phase and also the attack and tactic that this event is associated to. Once all events are added, we can see the attack to its fullest extent, being able to analyze and correlate all the elements that they have in common, including the targets of this attack.
The idea here is that, as you can see, basically an attack is all documented by these tactics. And you can see the recursiveness in this because it has the meta object there that basically establishes all this link. So that is a very brief overview of this framework. I will now pass to Madalina to showcase the pilot from Tim's side, auto processing of threat intelligence information.
Okay. Okay, hello everybody, can you hear me? Yeah. So I'm Madalina Baltatu, I work in the cybersecurity group of Telecom Italia. Especially I'm one of the managers of the threat intelligence platform of Telecom Italia. Okay, can you hear me better? Okay. So our use case in the telecom pilot was the automated processing of threat intelligence information. So basically, we wanted to provide an automated mechanism based on machine learning in order to assist cyber threat intelligence analysts with the task of indicator of compromise prioritization in order to allow the consumption of the most critical ones. So what was the motivation? Actually, back in 2017, when we started with our threat intelligence platform, we had a very enthusiastic approach. So we developed the platform, plug in the sources, a lot of sources, public, private feeds, and then we plugged in the consumers. So the CM, the antivirus, the EDR, and so on. And then we ran into problems because, of course, our CM analysts, SOC guys were flooded with alerts. And they picked up the phone and, hey, guys, you cannot go on like that. We have to sit around the table and define what is a priority for us. And, of course, we constructed a set of more or less static rules in order to prioritize the events that we received from all sources. But then we saw that we have a lot of sources which we didn't consider important that actually gave us indicators that were then involved in internal incident security, in internal incidents. So we, with Concordia, try to understand how can we use machine learning in order to have a broader view and a correct, let me say, prioritization of indicators in order to be sure we are not losing important indicators. The state of the art, when we started, we couldn't find specific solutions for our task, because our task was not to prioritize indicators that are coming from our incidents, which we know that were good and valid, but to validate, analyze, validate, and prioritize indicators that were coming for heterogeneous sources, which offer different levels, different degrees of contextualization to the indicator. So it was quite a challenging task. In the beginning, we found a paper, I remember, that actually said this was mission impossible and let alone don't do it. But we actually worked together also with Work Package 1 members, which are academia in Concordia. And they gave us some indications and where we were able to do something which is working now in Telecom Italia. So we jump into the achievements. So first we started with a collaborative machine learning based framework for analysis and classification of spam messages that targeted Telecom Italia. And the result of this research is published in a paper in Computers and Security Journal. 2 years in the anti-phishing group of a large company, and there you can find all the approach that we used and the analysis. And then we extended this framework to do a more challenging task, the prioritization of all threat intelligence indicators. And well, this is the first achievement. So we basically re-engineered all the email threat management process of Telecom Italia, because of course we, like any other organization, have commercial anti-spam filters. But we saw that 5% of spam is nevertheless forwarded to the users. And we have a collaborative framework because our user report, we have an automatic way to report the let me say, dangerous email or what users might consider dangerous, but it may be not. And this is integrated in Outlook. And nevertheless, we are confronted with thousands of emails to analyze every day. So we implemented this machine learning approach, which is using a set of classifiers. And actually, what the analysts now are presented, so the SOC analyst, is a dashboard where all the spam emails that were reported to them are also prioritized. They have a score, and they have some details in order to understand which features concurred in the prioritization and which algorithms prioritize the email. And they can focus first on these emails, and then they can go on with a best effort approach to process the remaining emails. I don't have results here, but I remember that with this system, we achieved more than 95% precision and 91% recall rates. So it was quite it is a system that is working, and it is very fruitful to Telecom Italia. And then we also extended this approach to analyze all the indicators of compromise that we are receiving from our sources. Also, these indicators are also shared with the CONCORDIA threat intelligence platform, which is based on MISP, as you could see from the previous presentation also. And well, now we have implemented and integrated these algorithms. And by the way, the best classifiers which achieve the best work here are RBF, support vector machine classifiers, and the random forest classifier, which combined together assure us a more than 90% precision with an average of 16 features. And the same applies also for hash indicators. So we have trained two models, one for the hash indicators, so malware samples, and the other one for network indicators of domains, URLs, IPs, and so on. And at the moment, we are in the consistency check phase. So the first results are promising. We are now retraining the analyzer because we extended somehow the feature set. And I hope that by the end of the project, we will share with our partners and everybody, because the deliverables are public, all our experience. And hope maybe in future to be able to integrate this approach into MISP. Because actually in MISP, it's quite challenging to implement from scratch. So we prefer to start from our internal platform because we know what is there. And, but hope to transfer not only indicators into MISP, not to share not only indicators, but also to have a plugin, the approach implemented in MISP, if we can continue, of course, with this work. Okay.
Okay, thank you, Madalina. I don't want to stand in between you and your lunch, so so I have to be quick about the financial pilot. I believe that there is a collaboration with Cyber for Europe, and it's about sharing information. Because before that there is incident sharing, but not much about indicator compromises. So, so the main focus is about sharing IOC. Okay, I jump to the automotive pilot. This pilot is focusing about charging for automobile and make it secure, because nowadays you can recharge your Tesla, but it's open for a lot of different attacks. So so the goal is to improve security to both your car and also the owner of the charger. About e-health, then the focus is about to cope with the shift in paradigm we are now facing an aging society. So for healthcare now, there is a shift from hospital to home. And then for ambulance services, then there is a shift about vehicle that is for transporting the patient now to a vehicle that allow the first aid, the first patient analyze, and also first treatment as well. But when we are doing that, we are facing a lot of security aspects which are on the device level, on patient level, on network, on communication, and also on the web. So this is a quite challenging task that this vertical is dealing with. By that, I just want to conclude and thank you for your attention.
I think we have time for just one question. Anybody has a question? No? I have one to Madalina. You talked about, so you have the spam that's reported and you retrain. To what extent is that knowledge that's produced by the machine learning, to what extent is it aging quickly or slowly? If you would stop retraining, would the performance will degrade because they will have new techniques and new approaches? Does it degrade quickly or does it stay valid for quite a long time? You have an idea on that?
Yeah, actually, we are studying this because this is something that we confronted in the first place, because we had a set of models that worked very well last year. And now, and now our platform changes because, you know, you change the sources every time, you change the IOC types, but actually, when at the level that we are working with a very, how do you say, with indicators like hashes, IPs, and which are always the same, of course, the attack type may change. And actually, we have today in Italy a lot of DDoS attacks. And the IPs are very dynamic, and their characterization is very dynamic. So our these kind of indicators are not working very good, let me say. So we saw that this year we needed a training, and I think that we need a training any 3 months, but we are not sure yet. Okay. This is something that we have evaluated lately, and well.
Okay,
yeah.
perfect. Yeah, it's the pyramid of pain, so the lower IOCs. Thank you very much. So I'll give you each a box of chocolates. There you go. Okay, thank you. It's well deserved. And so we will now listen to José María Torres from ECHO, who will be presenting the ECHO presentation on verticals.
Well, hello everyone. Let me introduce myself before. I am José María Torres. I'm project manager for Telespazio Belgium. And I am managing all the activities of my company inside ECHO. So my company has been involved in most of the work packages, if not all, but we have been task leaders for at least 2 tasks. And one of them is the integration of the prototypes, some of the prototypes that I will introduce here. So that's why I'm here. But that also means that I will be explaining things that have been done by other companies. One of them is present here. Here is third. So maybe some of the questions you will pose, probably I will translate directly to them. So I think you have seen this slide several times during these days. But I have pointed out here the multi-sector because it's something we will address here in this verticals presentation. And talking about sectors, we have started with the JRC taxonomy. And we have selected 4 sectors that have been the objectives during this project. And precisely for each of them, we have created one prototype. And I will go later to explain what will be these prototypes. So as I said, this part has been done by thirds, that before arriving to even developing the prototypes, there has been a big effort to identify what should do these prototypes, as they were not defined at the at the agreement yet. But what there has been is a big effort in understanding what could be the needs to be addressed by these prototypes, and not only this, by all the roadmaps that they had to be defined during the project. For this work, it has been impressive work, as more than 140 reports has been assessed. And the first objective was to identify what would be the challenges. And the team came with 83 technical challenges, and these were selected for a further analysis to trim them and identify which of them really needed to be addressed by our prototypes. And with this in mind, what we have done is selected 14 prototypes. That is much more than we were required by agreement. But the teams took the challenge of implementing so many. Finally, it paid off, because all of them has been implemented on time. In any case, I will not explain them, all of them here, but I will focus on the 4 of them that are really targeted to a particular sector. On top of this, there is also an important thing as the innovation roadmaps. These are things that are not being implemented yet, but with all what we have learned while implementing these prototypes, there came new ideas that we had to explore. They are all, as you can see, very innovative, as they are based on artificial intelligence, and one in particular, the AI/ML, cybersecurity for aviation, space, and maritime autonomous transport. This is really sector-oriented. It's a very interesting vertical here, the autonomous transport. Indeed, autonomous transport will require a good cutting-edge technology in artificial intelligence, but also artificial intelligence will be particularly, let's say, vulnerable for cyber attacks. But on the other side, artificial intelligence will be also used for addressing this problem. And this is an interesting innovation roadmap that is doing. It's been done, in fact, by Kai, as has been mentioned in the first day by Wim. Important that they are Ukrainian and they are still backing up and not leaving us. So this is a work package 4. I saw that the important thing I will comment here is the 14 early prototypes are the most things that are oriented to vertical and sectors. And AI/ML, I just mentioned before, it's also an interesting vertical here. Here we have already mentioned before the early warning systems all around. The reason I'm keeping this slide here is because I wanted to highlight the part of the sectorial. As Peter mentioned before, there was sort of federated system, and there are the so-called constituents. What I wanted to point here that this constituent can be really focused on the sectorial and on a particular sector. If Peter agrees, thanks, good. This, I think, cyber range has been already addressed good by Peter, so I will not go further here, and then I focus on the part of the so-called intersector prototypes tools. This is a work package where my company had to took some of them and integrate them. I will talk about this later, but as an introduction, these prototypes have been developed independently by each company. So indeed, the selection and what they had to do was done in common, but at the end, when they were identified, they had been implemented separately. And they have also been, let's say, designed to be working independently from each other. That means that some of them work with the early warning system you have learned before, or even can be deployed in the federated cyber range. But between them, they were not, let's say, conceived to be working with each other. But we had this task, and we really found good common places to make them work together. Another reason of having it integrated is that 14 prototypes is a lot. I mean, were many more than we were foreseeing. But it's also, even if we want to sell them, it's not so easy to sell one solution that's selling 14 solutions. That's why this effort of trying to integrate them and put them together is something important here. I wanted to mention here there's a development process. It's being Scrum-based. So all the teams have been really working in our bi-weekly basis all together and understanding what were the problems, the limitations. And the outcomes is clear. It's basically we have been able to implement all the 4 of them. It's really challenging. So these 14 prototypes that have been mentioning from the beginning, one thing I would like to do is that say that for the selection, what we really wanted to do is that at least they covered all the 41 unique challenges that have been identified at the beginning, and especially the 40 ones that we identified that they really had to be tackled. With this selection, we are able to cover all of them. I have to say also that we have selected 14, but there were an effort to select them because there were almost 40 tools initially conceived. Here, as we are talking about verticals, I would like to highlight these 4 of them. I have putting in bold the CISP because we will see a video. We will also see one video of CISO, but sorry, I forgot to put it in bold. So as these videos will really explain you this more in detail. I will explain that what CIMS and CYMS and AXMEA do. So before coming to here, and to understand, because 14 prototypes is not easy to understand altogether, important thing is that they have been grouped of what they do. So the red team, basically what they do is assess one system to try to attack them and understand them from an attacker point of view. What the blue team does is precisely defend it. And so it makes they can assess traffic, they can analyze logs. The important thing here is that they are defending one system. And the one in the middle, the purple one, as you can see, the mix of the colors. What they do is sharing the information that the other tools or themselves can learn. So these are the 3 things, important things to really defend a system. If you don't attack it, you will never know if it's really resilient or not. And with this context, to understand what they do, we have these 4 here. So for example, healthcare, we have CISP that appears here in the part of the sharing knowledge, because this tool basically what it does is supporting in a medical context to share the information about patients. It's something clearly very sensitive things. For CIMS, we have it in the defense ones. So the idea of CIMS in this context is that in a maritime environment, let's say when the attacks arrive, the people on board don't have the time to, most of the time they are not even expert in cybersecurity. So the challenge of this tool was really to try to make easier for the people on board to face these challenges, and especially when they appear in real time. I would like also to mention CISO. Here it appears also in the defensive one because they analyze logs, so it's one of those that are used to defend the system. And for AXMEA, as you can see here, is in the sharing knowledge thing. And this is also an interesting tool, but they assess in the scope of energy the failure modes. So really to be sure that no catastrophic failure goes through. So this is overall the 14 ones. So we don't have time here, so I will just put 2 videos that the teams have provided me, so I appreciate that. And well, before the videos, just to see that one of the objectives of these tools are to make them user-friendly. So you can see almost all of them have a user-friendly environment that will make it easier to find customers or potential users. Here we have another ones. In this case, are the purple team, that means sharing knowledge. And here we can see an example of CISO that we will see later on. I would have liked to explain them all together, but unfortunately I don't have time. So here there is one first video for CISO. I think it has sound, so I will let the people from CISO explain better what their tool does. Yes, well, I guess you have learned in the presentations this is space-oriented. One thing that has not been explained is what SCOS does. SCOS is, I guess, it's very, very space-oriented. It's a European system that really manages most of the ground segment nowadays. It's arriving to an end of life, but it's still very used, and it will be used for many years from now. So assessing really this ground segment is something important to help us to defend the space missions. So next one will be CISP. If you, yeah, we'll move. Here I apologize for so much text. CISO is CISP is a big system. I don't know if you had the chance to quickly see in the interface there were quite a lot of functionalities. That means that there was quite a lot of things to process. The main scope you saw is the important challenge of how to share and securize the information in the sector of medical sector. I think there was some, here sadly in Belgium there was one event in one hospital, some information kidnapped. So clearly this is a very confidential and sensitive information. Here I had to select this short video because we had a long video for CISP, but it's really, we're exploring all the functionalities, so it was a little out of the scope, so I apologize to Peter because he has worked on that. But in any case, what I will say here is that all these videos will be available on YouTube. So in the latest slide, you will see one link to really see these videos. So, well, here we will see once more all the 14 ones. Here what I would like to mention is that the challenges addressed were these 40 that they really had to be addressed. And as you can see, most of them are more than addressed because each of these prototypes is able to tackle with several ones. So that means that we cover all the challenges we had identified as important. And here we arrive to the part where my company worked is trying to put them all together. As I have explained, we are tackling all the challenges, but if someone new arrives and there are 14 prototypes, it's not easy to start over. So, and that's why what we had tried to identify in my work package is how to put them together to fulfill a mission. The part of the sector-oriented is clear because they have a specific function. But what we wanted to try in each of these workshops, we call it clusters, is to take one of the sector-oriented, for example, in this case was CISP or CISO, that we have just learned what they do, and try to securize it. So what we wanted to show in the workshop is like these companies that develop one system, they want to publish it. It has to be securized. And this is not an easy thing to do. So what we try to explain is in an interactive way with the people attending there to get ideas of how they would securize it. And what we were able is, for example, taking one of these colors. So for example, pen test, as I said, is one tool to attack. This is a tool to defend. So we were able to show with how with these two of them, we were able to securize a CISP, but as you can learn, it's a very sensitive information system. For CISOs, well, unfortunately, if you wanted to see it, it's already over, but we will have soon a new workshop where we will just explain again how to securize, in this case, a CISO system. For this, we will use different prototypes as one of the objectives of these workshops were also to show as many as possible. And then still in July, we will have a new one. Here I would like also to say, because it's very sector-oriented, they are the demonstration cases. But I will make it very briefly because Wim already explained at the end of his presentation, there was these nice images of the house where he explained particular demo cases. I think that's all for my presentation. Well, just come to the latest one is the dissemination. Like we have also work package to publicize all this good work we have been doing. And now I come here to explain what are the videos. So if you are interested in attending these workshops I mentioned, you can come use follow this link. And this second channel is specific for the prototypes, so you can see what they do in more detail. And that's it. So thank you.
So do we have a question from the audience? I will not ask a question this time because I know the work that has been done with an echo.
That's cheating.
That would be a bit fake. So thank you very much for attending and listening. Yeah. So I'll give you a box of chocolates. And then we have one more presentation before lunch, which will be SPARTA and Thomas Jensen. So the floor is yours.
Thank you. Thank you. So, let's see if we can get this thing working. Waiting for some slides. Here we go. Thank you. Super. Good. So yes, thank you very much for the opportunity to present some of the work that we've been doing in SPARTA. A special thanks to Gabriel Costa, who is the program leader of the Haiti program, who couldn't come here today, so who let me give his talk. I'll try and do my best. The topic of the Haiti program was the program was entitled High Assurance Intelligent Infrastructures. And the goal was to try and do secure by design, build these architectures, building security in from the very beginning on. So the challenges that you're faced with in these, what we call intelligent infrastructures, is really that there's a heterogeneity in the network, where you go from very, very small devices and all up to the orchestration of all these independent devices that interact. And that is the overall setting of the Haiti project. And as you will see, we'll address a number of security issues or facets in the project. A little overview of the work package. It was one of the work packages of the SPARTA network. Lasted for 3 years. It's just about to finish now, with a dozen or so partners involved. And the program was structured into a number of tasks that addressed sort of each of the each its own security aspect. So, for instance, we started looking at how to secure the operating and the system software that run on these devices, because, well, that was mentioned earlier today that some IoT devices can rely on TrustZone or SGX. Well, we are looking at quite different things which would not necessarily have the same protection mechanisms. So how do you deal with that? I'll return to that point in a few slides. Then, of course, these infrastructures use legacy components. Also, we heard this earlier today. And there's a challenge in how to make sure that the components, both hard and software, you install, you use to build your infrastructure, that they actually give you the necessary trustworthiness. A central point of this project, and there Gabriele could have told you much more than I'm able to, is how you orchestrate all these devices in a secure manner. But that was the goal of the third task here in the project. And then we had 2 other tasks that were dealt with sort of resilience of the infrastructure and also surveying it. How do you do that using intrusion detection techniques? And the final task was to deal with how do you also build in privacy from the word go. So that's the overview of the project. And so that's what I'm also going to talk about here is one of the sort of the applications we made of this in a particular demonstrator to deal with smart buildings, as you'll see later. Yeah, just a little thanks from Gabriele. He's very keen on this because there was a very good work in collaboration in the working group, despite that we had to go virtual and even had a hybrid meeting here last year in the setting. So I think we'll just skip that one. The interesting thing is that, so here you have perhaps a slightly complex overview of the SPARTA project. As I said, the Haiti program was one of the work packages that sort of put together in SPARTA. And there were certain interactions with other work packages. For instance, the work package 2, we dealt with ethical and legal issues because those are, of course, present in these infrastructures as well. There were also work with the automated verification work package. And even though he didn't put it on here, we also had discussions throughout the network with the roadmap working group that I was in charge of, because of course the program had its roadmap, and as they went along we discovered more and more issues that should be added to that roadmap. So in the beginning, so the idea was, as I said, to try and the goal was to engineer into the construction security from the design. So the starting point was to take sort of a life cycle of development of such an infrastructure, taking the design and the validation phases, deployment, the testing, and then finally actually running it and monitoring it, and see where, for each of these phases, what was needed in order to engineer into this the security from the word go. And there was, to do this, then in the work package, in the project, we developed a number of methodologies that were then embedded at different stages where they would fit in. So to be a bit more precise, there were, for each of these tasks that I mentioned before, there were a number of, shall we say, more technical contributions made during the project. So if we take as an instance, for instance, just the first task, which dealt with the secure system software, secure operating systems, then for that we have developed new crypto primitives that run on these very low power, low resourceful devices, where you cannot use your usual crypto primitives. So they had to be developed, they had to be certified, and they had to be put into these small devices. There's also a use of a particular operating system. That was why I asked the question earlier today, because we focused on a particular operating system for the IoT called Riot. So Riot is basically used wherever you, if you can run Linux on a device, then Riot is not for it. But everything that goes below that, then Riot has something to say. So part of the project was also to build more security into Riot and use this as sort of the, shall we say, the basic system for the IoT devices of the infrastructure. And in particular, what we were looking at was to combine this with the crypto in order to make sure that we could update in a secure fashion these IoT devices as we go along, to have a secure, shall we say, supply chain of new software for these devices. Okay, so that was the little technical focus on the first task. As you can see, some of the things went into the design phase, but also other things, of course, when you need these updating techniques when you're actually running the system, so they impacted on that phase as well. Then the second task dealt with sort of the hardening of all both the hardware components and the software components. We already heard about this in an earlier talk today. And then task 3 was about the secure orchestration. How do you put all these very heterogeneous devices together in a coherent architecture, how they can communicate? Well, there's a little example of illustration of that in a slide to come. The final task, as I said, dealt with the intrusion detection, as we also heard before, and sort of this last task was about privacy preserving. How do you engineer that into this architecture as well? So that was sort of the technological basis for this, and then we actually want to do a real case study. And it was chosen to be look in the area of smart buildings. So over there, you see a building in the Savona campus, which is part of the University of Genova. So they have built this campus and equipped their buildings with a lot of sensors, and I think they also have some power grids installed there, so they can both charge cars or even do a reverse charging. So there's some quite sophisticated architectures there. So in our big ambitions, we said, okay, let's go and do that and then deploy our architecture on that at the end of the project. That turned out to be a little bit too ambitious, also because those who actually installed all the devices and made the buildings said that, well, we're maybe not quite happy with you going and sort of messing up with our devices. But nevertheless, instead, we sort of went on to build a model of the whole network, and then studied that for some different security scenarios. And this is something that is publicly available. There's a paper on computers and security that's going to come out that describes this network and how the tools behind these structures. So this is this is really where Gabriel would have done a better job, because this is his baby, about how you can model these networks, and you can sort of reason about the security of these arbitrary security workflows, as he says. And I think I'd better just let you, if you're curious, contact me or contact Gabriel to get much more information about this. So I'm wrapping this up. Gabriel concludes that there is no silver bullet in security. I think we know that. But here we've been able to, in this project, we've been able to demonstrate that there are a number of security mechanisms, often also dedicated to a specific domain, and that you can actually put together and to build a coherent network of these intelligent devices. And we've done one demonstrator for this, but the framework that has been developed in the Haiti project is more general than that, and I invite you to look at the tool that came out of that project. So I think I'll stop you there, and we can have some questions. I'll try and do my best to answer them or send them on.
Okay, thank you. Are there any questions from the audience? I think nobody is risking his life by standing between questions and lunch. So we'll wrap up here. I think we had an interesting presentation of how the different pilots have viewed different verticals and the types of demonstrators that they built and the types of prototypes and so on. So thank you very much. And thanks also to all the other speakers. And I wish you a pleasant lunch and interesting talks around lunch. And then we'll see each other back after lunch, which would be at 13:45, I think. 1:45. Have a good lunch. Thank you.
Test.
Test, moi je t'ai entendu.
Test.
Test.
Hi. Yeah, okay. Are we connected on Skype? Yes. Okay, we are connected. Can he hear us? Okay, that's great. So, welcome everybody to this session. We are going to talk about perspectives from JRC ATLAS and ENISA. Unfortunately, our first speaker, Francesco Barbato, was not able to join, but we are going to have Vide Hogenhut joining us remotely via Skype. He has earned his PhD in Japan on language processing, and after that he joined the European Commission in 2004, working for many years in Future and Emerging Technologies, the FET. He joined the Cybersecurity Technologies and Capacity Buildings in 2020, and he worked on conditional performance and security, and more recently in security operations centers and the DEP, the Digital Europe program. If we are connected, we can start with his talks and slides. So, hi, nice to see you.
Hi.
So, please go ahead.
So thank you very much for that introduction. I see, excellent, there are the slides, very good. So indeed, Francesco Barbato is not feeling well. I'm sure he'll be getting better soon, but it could not be there with you today. And he asked me to take over. I'm sorry that I have to do this remotely. So if you could go to the next slide. Thank you. So the European Cybersecurity Atlas, it has been around for some time now. It started a couple of years ago when, amongst others, the Commission decided to do more, let's say, networking of the cybersecurity community. Now that is, of course, part of a much bigger picture, and I understand that yesterday Martin Uberhor told you about a lot of the things we're doing in relation to the competence center that's going to be in Bucharest, and other activities related to that. But one of the steps we took, sort of building towards that, is to start off with the European Cybersecurity Atlas. If you could go to the next slide, please. Next slide. Thank you. So why the Cybersecurity Atlas? First of all, it perceived need to have some kind of online portal where we could see information about all the stakeholders, all the actors in the area of cybersecurity, where knowledge could be shared, where we could see profiles of researchers, or where we could see what kind of collaborations there are. What would that do for us? Well, it would help us to establish a community and do some, let's say, community building. Being able to see who is who and what is happening where, who is working in which area. Helping to identify opportunities for collaborations. Also, let's say, for people working in the field who else is working on the same topics, or also what topics are not being addressed. Maybe there's almost nobody working in a certain topic. Then to map these competences so that if, for example, decision makers are looking for stakeholders to consult so that they can see who is working in a particular area, who are the people to go to. It's, in a sense, a knowledge management tool. It also raises the visibility so that people who work in a particular area become more visible. And there's, of course, a certain element of coordination, so that when we think about what are the strengths of Europe, what are the weaknesses, where there's maybe a lot of people working in a particular area or very few, what are good areas to invest in or what are not so good areas to invest in, that this kind of information helps us a lot. That helps us to make the funding programs, that helps us to execute the funding programs. And more in general, it is a way to provide information to policymakers. Now, of course, this is something which is something we're building up. we started inviting the members from the 4 pilots to join this. Of course, once you open this up, there's also, for example, people who think they become a cybersecurity expert by simply being listed on this website and without having to ever study that area. Of course, there has to be some kind of control on who gets listed there. And of course, we're building these on the 4 pilots, not everyone in Europe. And also, we're in the same time, we're building up the ECCC, the NCCC. So at some point, we will have to see how does this fit in with the things that we're doing for the competence center, and how should this evolve? Because it should somehow evolve and become an online portal for that in that context. Next slide, please. So I guess Martin must have already told you about the competence center that we're building up, which will be linked to a network of national coordination centers. This is very much an ongoing activity. The member states are appointing or proposing those national coordination centers. We have a call for them in the Digital Europe program to help them set up such coordination centers. And there's also the competence community, which is a diverse group of stakeholders, private and public actors. And they're, of course, very important to the competence center for many of the reasons that I just mentioned with the previous slide. Now, in the context of the competence center and these coordination centers, there's currently a number of working groups. There's one working group on community memberships that looks at questions like how to assess if somebody should be a bona fide member of this community. There is a working group on the functioning of all these coordination centers. There's one on the service catalog, what sort of services they should provide. And in a sense, what we're doing in terms of community building in this atlas, it links to many of these. So a lot of these discussions sort of touch upon what we're doing in the security atlas, what we have done, and how it should further evolve in the future. One key element, of course, is there that so far in the atlas, there's been sort of an ad hoc solution to how to moderate that, how to, for example, assess who can join if there's, for example, ad hoc requests. And we need to see how this clearly is a task. In the regulation, it says that the national coordination centers will have a role in assessing who can be, let's say, recognized as a member of the community. There's a discussion about the sort of service catalog of the national coordination center. So that also links to if there is sort of a platform where you stage information at the European level, then the discussion, okay, what is the kind of services that you would offer, and how can we make a platform that would allow them to offer the services that they should be offering. Next slide, please. Now, the competence community is diverse. There are academic and research organizations, public authorities, the union bodies. Of course, this industry that is depending on, let's say, the demand side of cybersecurity. There's the supply side, where, of course, EXO has been a very important stakeholder in our discussions. And then there's other stakeholders. And this community plays a very important role in all sorts of ways. We want to support the competence center in achieving its mission, its objectives. Of course, there's a lot of dissemination, a lot of informing to be done, for example, about our programs, about other opportunities, about possible projects being launched at national level with industry, or whatever it may be, events that are taking place. There's activities the network may promote. There may be working groups to on specific questions. Of course, if there are projects, then it may also be stage to promote the outcomes, the impacts of those projects. And the national competence, the National Coordination Center specifically have a role of being a point of contact for the community, of also, for example, giving support to applicants who are applying for example, European programs, and helping them sort out all the bureaucratic hurdles we throw up. Then, as I mentioned, assessing requests to become a member and their role in dissemination. Next slide, please. So where did it start from? A number of years ago, the JRC made cybersecurity taxonomy. This was one starting point, and of course it played an important role because the atlas sort of identifies where we have certain, where people are active, and then it's important to have a common vocabulary. There was a patent and research analysis done, of course, and also a survey was sent around. And of course, the patent research analysis and the survey were very important in identifying a lot of the actors that could, let's say, be relevant stakeholders to be taken up in that atlas. So to have a landscape of who is involved in cybersecurity in Europe. Next slide, please. Now, this is a picture from a report from 2019. This is actually a second version in the sense of that taxonomy that the JRC made. They made a first version, I believe, that was in a report from 2018. Then the 4 pilots were asked to review this, and this is then a second version after that review. And it identifies, first of all, a number of sectors, then a number of research domains, and a number of application and technologies. This has, of course, been important, and it continues to be very important, especially because we are increasingly also in other domains looking at setting up collaborations in cybersecurity. And every time the question comes back, how to have a common vocabulary and how to make sure that we use, for example, a common taxonomy somewhere. So this is always a prime example, like, well, why don't we use this one? So what is the goal? Well, the goal of this taxonomy was to make sure that it could be used by all the cybersecurity institutions, that it would be a point of reference, and that it would be, let's say, a useful way to index the research entities that we have in Europe. And of course, it also has to be sustainable, so it has to be sort of extendable. It should not be something which is fixed and which cannot cope with new developments in the area. Next slide, please. So the survey was sent to more than 700 centers in Europe. It was conducted in 2018. It sort of played an important role in the atlas, but also more and more generally in our thinking. Some of the conclusions are that, first of all, there's a lack of coordination between the different member states in what they're doing in their investments in cybersecurity. Let's say a lack of awareness of what the other countries are doing, which is, of course, not a problem that is unique to cybersecurity. There are many different domains where we find this problem again and again, that European countries often lack, let's say, having a good reference of what happens around them. Then another conclusion was that there's an important disconnect between the industry and research. There's a lot of very relevant research. There's a lot of publications from Europe. Of course, we have our industrial players, very good industrial players, but in a sense, there's a kind of two separate races being run, one by the industry, one by the academia, and there's not enough interaction between them, or at least that was one of the conclusions from this survey. And then another conclusion was that many of the institutions which work in cybersecurity, if you map it out on this taxonomy, they actually focus on a very small number of fields. So it's sort of striking that there's a rather strong specialization in quite a few of the actors. Next slide, please. Now, I will not spend much time on this. This is just to show that there's also there was a look at the patents in cybersecurity. Of course, there's a big growth in the number of patents. It's a very important area. And actually, I think it might be interesting to go back to this at some point and maybe see with the European Patent Office if they should do an analysis of the current status of what kind of who are the major players now in terms of patenting in cybersecurity. Next slide, please. So now, of course, when we built the Atlas, we also have to think of what do we have so far, who should be in there, but also what role can it play for whom, and how should it develop in the future. Here are some of the stakeholders. We are looking at research institutions, industry, startups, students, researchers, job seekers, market analysts, policy analysts, etc. There are also some questions you can ask about where should the Atlas come in, where it would be useful. Of course, one of the most immediate things where it can serve is that it's kind of a yellow pages of the community. You can find out who works in a particular area, who are key stakeholders. It may be relevant for job seekers who are looking for a position, who want to specialize in a particular area, researchers who are looking for people who work in the same area as they do, students who look for opportunity. It could be a place to promote events and that sort of thing, and so forth. Can you go to the next slide, please? And that, of course, then raises a number of questions, such as who are the main resources in Europe? What are the networks? What are the time dynamics? What kind of topics are being combined? And with a lot of these questions, of course, you would also ask the next question, namely, how should you extend the Atlas? Who should you take it from here? There's been a project that's, I believe it was Cyberwatching, which made a whole map of the different projects that are in Europe. So that is, of course, one thing you could do. Then you could think of news events to make it a sort of a place where you can discover new things. There's also questions such as happening in terms of funding at the European domain, but also at the national domain, for example. What kind of opportunities are out there? So these are all questions where the Atlas could potentially be a very, very good research. At the same time, so if you could go to the next slide. So that gives us a number of potential benefits that we could have from the Atlas. Networking, so allowing, let's say, a tool to find out ways to find out who is in your research area and to enlarge research networks. Creating visibility, becoming a, let's say, preferred source of information of activities in cybersecurity. Then there is a contribution to EU policies. I already mentioned if we want an initiative in a particular area and we want to find out, okay, who are experts in this particular area. There are sectoral activities developed by ENISA. This could be a link there. Then there is, it could be a source of information on projects, on courses for students, on job listings, and so forth. If you could go to the next slide. So at this point, there are 846 organizations in the Atlas. In 2021, we had 200 new enrollments. And here you see the overall distribution. I think maybe not so many surprises to me. Of course, big countries have more than smaller countries. It's logical. Being Dutch, I compare Netherlands and Belgium. They're about the same level. Okay. But what we do see is that there is a continued interest. There's a lot of stakeholders that contact the Atlas and that would really like to be listed there, would like to be visible there, and it's also quite an effort in making the assessments. So you could go to the next slide. So this gives an idea of the kind of organizations that are in there. A lot of academic groups, a lot of research organizations, then a number of some laboratories, a number of higher education departments. And then on the right side, you see all the domains where they're active. Of course, many of the organizations are active in multiple domains. A lot to do education and training, a lot of data security and privacy. And then you see that it sort of goes down to less popular topics, although of course it's still a substantial number, even at the lower part of this thing, except for the last one, steganography. Of course, this is a self-declaration, so this is where people say they have expertise in. It's not some kind of assessment from somebody else inside. Next slide, please. If you could click again, because I think now there's a picture. Yes. So how does it work at this moment? So there's the commission, then there's the pilot coordinators in EXO, and under that there is, say, the community, the EXO members who then get listed. This is the current setup, and we have to transform this, let's say, hand this over to the competence center and see how we do the governance. And this is one of these discussions which is now ongoing, namely, how would that work? If we think of, let's say, there are 27 national coordination centers, then, you know, they are all looking, of course, at the question, do they each want to, let's say, very much have their own space, their own tool to do this, or should there be a common tool that everybody uses? Of course, it's logical, it's natural that they should have some kind of place where they can promote their national activities. So as I mentioned, that's a discussion which is now ongoing. And it also means that the whole thing is in flux. We've taken this up to a certain point. Okay, we have to start from somewhere. We don't want to, let's say, at some point say, okay, now the ECC exists, and now all of a sudden we try to think of something. So this is kind of building up towards what it should become, but there is now a discussion ongoing on how to do that and how to, let's say, make this function in an efficient way, but at the same time give the national contact centers the role that has also been, you know, to some degree, the regulation gives them a certain role, for example, in assessing new members. But also there's a discussion on how to now make that work, both from the governance perspective, as in who takes decisions about what, but also from the very technical perspective of, do we use a common tool, do we use a common API, do you have to have, let's say, one API where everybody makes something which is interoperable, and so forth. Next slide, please. So this is the last slide. So the evolution, as I mentioned, it's transforming from something, let's say, for us in-house to a federation of portals of the national coordination centers that is linked to a communication strategy at a European level. Okay, there are lots of questions around it. How can we create a European stage to disseminate, to promote the activities, the results of all the work that's ongoing at the European level? Visibility beyond national borders, collaboration beyond borders, how that all works. And at the same time, we're also working at improving this under the hood. There is a taxonomy, and as it's with databases, if you can only do very simple queries, then there's only so much you can get out of a database. So we're now looking at using semantic technologies and making a transition to ontology to be able to, let's say, get more value out of the data we have. And that's the last one. The next slide is the thank you slide. So thank you very much, and I'll be happy to answer any questions.
think we have time for questions. Are there any questions? Yes, over there.
Hello. Hello, I'm Isar Cañameras from the Cybersecurity Agency of Catalonia. And I wanted to ask, why should companies, for example, in my region, register there? I mean, who is actually using the Atlas and for what purpose? And that's one, giving that to the audience, maybe. As people participating in European projects, finding consortiums, does any one of you have used the Atlas for finding a partner?
Okay, we start with the first question to our speaker.
Yeah, sure.
Yeah.
So, as I mentioned, there are a number of benefits of registering the Atlas. It gives you visibility. It's let's say, functions to some degree as a yellow pages of cybersecurity in Europe. So it allows others to find you and also to say in one framework express where your strengths are, in what area exactly you're working. At the same time, and of course, you could also think of further advantages further ahead, such as, for example, finding people, finding new staff. There's a big shortage of people with cybersecurity knowledge, so you may want to look for staff and that can play a role there. At the same time, as I mentioned, this is something ongoing, so I would also turn the question back and say, as we are building this European platform and as each national coordination center will have its role, what shape should we give it to create a maximum benefit and to let's say, make it as attractive as possible to be on there and to gain benefit from that.
Sorry, sorry. I mean, it's not criticism, although the question at the beginning was kind of punchy. But the thing is, I may be willing my companies to be there, and I may be an ally for that to happen. I can do that. I can invest in the companies in my region to be in the Atlas, but I have to think about the effort versus benefit. And of course, that's why I was asking the question. Thank you.
I think at this moment, the effort to get registered is quite small. So I don't think it's a big investment to be registered here.
A pleasure to see you again with this. So it's a pity you were not here yesterday, because I've been asking this question from different perspectives all day yesterday to the representatives of NCC, ZCCC and stuff, and to the Commission. So I'll ask you this, more or less the same question from a different perspective. So it seems that the Commission is leaving the community to the NCCs completely. And so why is that so? And the second related question is, why is the Commission not using the large amount of funds that he put on the 4 pilots to kickstart the community with the 4 pilots? So in 6 months' time, the 4 pilots will be gone, and it seems that the Commission is doing nothing to keep them alive as a community. So you have more than 160 organizations that already form a community, that have worked together for 3 years. We have this huge event going on these 3 days here in Brussels, and we don't have representatives from the Commission here. So why is that? So as I said, so I take the freedom, because I mean we know each other, so that I can put this question very bluntly to you.
First of all, there were 3 questions. First of all, why don't we do the community building ourselves? Then why not continue with the pilots? And then our presence here. Now, to start with the first question. over the years, I've seen many projects doing community building, and it requires a specific, let's say, a specific mindset and a specific approach. In fact, I'm even not sure if scientists or technologists are the best people to do it. The one person I know who did the best job in it, I've seen in my entire career, was somebody who was completely not from that area at all, but who just had a talent in community building. Now, of course, the pilots have had an extremely important role in bringing together 160 actors. I mean, it's huge, and it's very important, and it's had a huge impact in bringing together many players all around Europe, making people aware of what's happening, getting people to work together. So in that sense, it's extremely important. Now, there is also a question of how do we create a competence center that is able to effectively take into account the community. It's important to realize that the competence center is not just a machine that does evaluations. It is really setting a research agenda and executing that. So it's much more. And because of that, I can't even imagine that we, and Afonso, you know the few people that we have in our office, that we would do the community building and then somehow transmit the results to the competence center. That makes no sense. So I think they have a very direct interest in working with the community. And then there are many local things happening. As always in Europe, there are small local events, there are bigger events, there are cross-border events, and so forth. It would be very difficult for this competence center to do that all by itself without having any support from local community. So I think it is a very important and very good choice to, let's say, to create this network and to have this support so that there is an opportunity for national competence centers to promote local events, to do things in the local language, to see local opportunities, to see how they can help people from that region or that country to be more, let's say, successful in funding, to develop their own expertise, to develop a certain skill and so forth. So that's why I think that's a very good thing. Now, for the continuation of the pilots, of course, we are looking at where we can extend and what we can do, but at the same time, you know how the funding system works. We cannot pull money out of a hat and say we continue with the pilots forever. That's not possible. Maybe in the context of the competence center, there will be new projects and new ways of working, but that will have to develop. And I've seen it in previous areas where I've worked, and I see it again now. It's always very hard when you have such a large and very, very successful effort being built up, and we have no choice. Okay, money runs out, the grant runs out. What can we do? That's it. So we can try to think of new initiatives, launch new initiatives, but we cannot keep on continuing this forever. So rather than I would say let's try to make the most of what we have in these pilots. They're very important and they have great results. And let's at some point accept the inevitable, and also let's think about what would be the new initiatives that we want to launch, and what would be the best way for the competence center to recreate or make a new version of this, so that this community can work together and be effective. So it's where I would say, if I could, I would let these pilots continue forever, but that's not a possibility. And then as for our presence there, so I'm really sorry, and I wish I could have been there today, because I was really looking forward to meeting some of you, and also some of you, and also you, of course. Unfortunately, we are in an extremely difficult timing, and we have in our unit very limited resources also. As you may know, the DEP call just closed, so I'm now very busy looking at the proposal that came out of the DEP call and finding experts and so forth. And in the same time, there's a number of legislative actions ongoing. There is all these discussions that follow from the crisis that we have in Ukraine, what have you. So we are under extreme pressure, which is also why I could not make the time today to come to the center, because I have another meeting starting soon. So yeah, what can I say? We do our best, but let's just say we follow very closely. But there's only so many things we can do.
Are there any more questions from the audience? Well, if we have time, I have one more question. Vedi, I know that you have been involved with other communities in the past as well, like the graphene community. Are there any, say, best practices or good ideas that we can copy from this community and adopt in our community, the cybersecurity community?
One of the things that I have followed with a lot of interest, and that I think could go a lot further, is that in the graphene community, there was a huge effort from many people in the community to make a very detailed roadmap on where they wanted to go, really over a longer time, with a lot of the technologies, a lot of the things that should happen. And that actually became kind of a big reference for people all over the world. And I would say this kind of road mapping is very important and very helpful, also because, as you know, once the whole thing gets going, you need to make research programs. You need to make programs like Digital Europe, which are more about deployment. And there's a lot of, we face these questions of, okay, what we put into these programs? And from that experience, I know it was extremely important to have that, and to have really details on what should be the next steps. And in that context, here's also the narrative, because when it comes to each of these areas, having a strong narrative is really important for example, getting funding. And in that case, I have to say that I must say for your community, it's a lot easier, because with every cybersecurity incident that happens, your narrative becomes stronger. So there's a lot of support already, but narratives are important.
Okay, great. Oh, there is one more question, Christos.
Hello, thank you for the presentation. I would like to ask how dynamic is this atlas and how easy it is to update? What is the procedure? Is it a Wikipedia type procedure? Some people meet, you apply? Because from my personal experience, we had to update our graduate program in cybersecurity because it took forever just to declare it, and then it's not very easy to change that. And this will be more difficult for companies. How do you accept a company that declares that it does this high-end research or development in cybersecurity and so on?
That is a very good question. I was involved in the Atlas in an earlier stage, where we had to face that immediately. One of the reasons for starting with the pilots is that it was kind of not so complicated to assess, because basically we can make the assumption that if you're in one of the pilots, then you're a bona fide cybersecurity stakeholder. Now, after that, we started receiving ad hoc requests of people who contacted and said, could you please list me? And some of them were completely not somebody you would want to have in there. But some also very valid and from very bona fide stakeholders. It was then initially decided, and this is being done by the JRC, that some people in the JRC were looking at that and using some criteria to make that assessment. It's not an easy question. And of course, this is also the reason why there's now this working group from the NCCs or from the Cybersecurity Competence Center on the question of how to assess community membership. And that also is the reason why in the JRC sometimes, I mean, they're also overloaded, but sometimes they get a request, and it's sometimes taken some time, but at the same time, you know, where we see that, we've been trying to improve that, to be able to be more responsive. But yeah, they had to make some hard choices based on, and also develop, let's say, the criteria to do that.
Okay, great. I think there are no more questions, so let's thank our speaker once more. And our next speaker is Marco Barros Lourenco, who is a technologist and researcher in the field of digital policy. He has had a career spanning nearly 30 years, 20 of which were spent in international organizations and multinational corporations such as the World Bank, the EU Council, the United Nations, Microsoft, and the EU Cybersecurity Agency. For nearly 2 decades, Marco served as an advisor to several governments in Africa, Europe, and the Middle East, particularly in the area of digital policy. He helped define national digital and cybersecurity strategy for more than 17 countries. Since 2018, Marco has been responsible for the Research and Innovation Program for the European Union Cybersecurity Agency, ENISA. Marco, please.
Is it on? It is. Well, while we're trying to get this going, so first of all, allow me to be very grateful for the invitation, for inviting ENISA and be here today. My responsibility at ENISA is to lead the Research and Innovation Program since last year, since the beginning of last year. But I'll give you a brief introduction of what we're doing. If you could just pass to the next slide, please. So I'm going to introduce ENISA just very briefly. I believe that... I do. Oh, indeed. It's the green one. Okay. So probably most of you know ENISA, I hope, at least. But ENISA went through a great transformation during the last 3 years. With the promulgation of the Cybersecurity Act. And during these 3 years, we welcomed a new executive director. And also the work was just to identify a new strategy and also adapt the organization into the challenge of delivering a new mandate. And that it was basically a turning page for us. And also in terms of the way we support the member states, the way we interact with our communities, and also the way we support the European Commission in developing and implementing policies. Now we are, as you were aware, we are just about to discuss, and we are currently discussing the new version of the NIS directive, that it is a very important piece of legislation. But there are others coming, like the Cybersecurity Resilience Act, and others that are also equally important. And ENISA has the opportunity to interact in these fields, be able to provide advice, also talk to the communities, understand and bring feedback back to the policymakers. And this process is something that is being very, very interesting to observe in terms of how ENISA throughout the years, and some of you, I believe that followed the inception of the agency almost 16, 17 years ago, and see the growing importance of the agency in terms of the cybersecurity ecosystem in Europe. Come back, just... So, as I mentioned, during the last 3 years, we defined a new strategy. And the main reason why I'm here today, it's because with the Cybersecurity Act, the member states, the legislator introduced the Research and Innovation article and a mandate for ENISA. But also another important aspect that I'm here today as well, it's because we put the community in the center of everything we do. And we're, just before me, Vide was mentioning about the community, and I believe that it's all about community in terms of the 4 pilots and also the Convergence conference, to make sure that the community is built, it's developed, it grows, and is inclusive and covers all the spectrums of cyber. Just to very briefly give you an idea of where we are positioned and how we are organized in terms of the agency. As you know, we received with the new mandate the cybersecurity certification. That is a very important instrument also for the Cyber Resilience Act, but for us to move on in terms of getting products in Europe that are certified for cyber. The role of ENISA is to develop schemes, certification schemes that will be used by the member states to start certifying processes, products, and services. Other aspects like, for example, capacity building, education, awareness raising, traditional areas of cyber. Also in terms, we are also implementing a new capability on operations, and also in terms of not only for Europe, but also internationally, in terms of our continued work in developing and implementing, not developing, but in terms of our support to the European Commission and to the policymakers, in terms of our support to the cybersecurity policy development. Apart from that, also as an horizontal, we also do other activities related with knowledge management and information, and also on foresight. On foresight, we're trying to identify trends, with signs of change that will point us to a direction. We just very recently ran an exercise in Athens where we organized a threat hunt for 2030, and we bring some experts and stakeholders to discuss how they see cybersecurity evolving over this decade. So a lot of things are going on, just to give you also an important aspect is to make sure that that we have a strategy that is fit for the challenge in terms of how we position ourselves, according to a vision that was defined and agree with our stakeholders, of course internally at ENISA with the executive director. We defined 7 strategic objectives, and again just to highlight that the first strategic objective is to empower communities. And that is our main focus, and I'll come back to that point later in this presentation. As I mentioned, so we have a new article, Article 11 of the Cybersecurity Act. And this article states that ENISA should advise the member states and the European Commission in terms of research needs and priorities. When the Cybersecurity Act was approved and published, there was no idea, or at least there was just an intention of setting up the European Cybersecurity Competence Center. But at that time, there was already an idea that ENISA should play a role and should act in terms of identifying opportunities for research. And that's, in terms of my responsibility and my role at ENISA, is to make sure that, I bring all the parties together to be able to deliver on this mandate. And I think that is an important thing that it's not reflected in Article 11. It's that we're not supposed to be a research organization. We don't do research. And I think that is a very important aspect, because being a technical body of the European Union, we're not supposed to bring researchers into our organization, but to work with the research community. We are supposed to create the interlinkages, to be able to empower the community so that we are able to flourish in terms of the products, the services, the innovation in the cybersecurity space. As I mentioned, the role is to advise. So, and how we are planning to do that. We're planning to do that, first of all, and I think here I had the benefit of talking after the Commission, after VIDE. So, and I think that is important for me just to understand that we are basically advisors. So we're not an entity that would have the ability to provide any funding to projects, but we are the ones that advise and identify what are the needs for the funding programs to look in terms of what should be considered as a priority. And that is our role, basically. And I think that is important because for us, it gives us enough distance to also be seen as members of the research community without doing research directly. We want to partner, and we don't want to, we want to have a role that we are seen by the community as someone that could help achieving the objectives of the community. So a part of that advice, I know that yesterday there was the presentations made by the European Commission and also by the co-chair of the Competence Center and by the chair. I'm not going to talk about the Competence Center, but just to tell us that the legislator made it very clear in the regulation that ENISA should make sure that there is consistency within the work of the center, meaning that there is a lot of entities in Europe working in cyber, and the center should be an instrument for the European Union to invest funds or make investments into the cybersecurity projects. But we need to make sure that there is consistency on that, that is complementarity. We don't want a center that will continue investing on the same things. We want to progress. We want the center to invest in areas that are innovative, that are new, but also acknowledge what already exists, the work that has been done by the research community throughout the years, acknowledge that and be able to promote an uptake and scale up so that more products, more services, more innovation comes into play. And that's what we'll be pushing for. And our role is very clear. We're advisors in the governing board of the center. We are supposed to work directly with the center, with the executive director, to make sure that we also serve as an instrument and a vehicle of the ideas, of the needs from the research community. So my presentation today is basically one message that I would like to convey to you. I've started my mandate last year in this role at ENISA. And last year and this year, I'm trying to contact some of you. I've already scheduled calls. I'm scheduling visits. What I'm trying to do is to get to know you and understand what you're doing. So we're able to establish that we serve as someone that could establish bridges, that could bring also that information about what you're doing, the progress that you're achieving to ENISA, but also to the member states through the Competence Center. And we'll continue doing that throughout the year, throughout the years. And an important aspect that we're talking today also, it's about Atlas. And there were questions about what is the value of Atlas, what can we take out from that system. I think that Atlas retains a lot of information about who we are, what we're doing, and about where we're located, what are the sectors, a lot of information about us. But that doesn't serve a purpose. It's just the database. It will be up to us to identify what will be next. What can we do without that information? Can we establish ourselves as a community? So the title of my presentation today is How We Build a Stronger Community. We know, I've seen it, I've interacted with many communities while at ENISA, like, for example, the CSERTS community, also the ISACs, and many others. And I think that it's important that we also create a strong community for researchers and innovators that are working on cyber. And that will be the success for us, but also in terms of the vision that was established for the Competence Center. So coming back to the topic of Atlas, we're coming up with different ideas about how can we mobilize the community, starting with the starting point of Atlas. The intention will be for us, from our perspective, and that's what I've been discussing with many members of the community, on how can we progress into the next stage. I've discussed with many people saying that we should not only focus on cybersecurity professionals, or we should only focus on companies and entities that are delivering only cyber. We should also call people like, for example, from law enforcement. We should also, that are working on cyber. We should also involve the entities that are working with defense. We should involve lawyers, people that are working in legal aspects of cyber. We should involve also people that are working in psychological, societal, and other topics. We should make it a community that is inclusive so we can have the debates and the discussions and run the projects that are multidisciplinary, that cover different angles. And we need to understand and we need to create a framework and a concept of something that will serve the purpose in terms of moving into more innovation. Came back to the previous one. One of the aspects that I've also been discussing with members from the community is the fact that it's important for us to have visibility within the community of who is doing what. One of the aspects that we've been discussing with the member states, it's the possibility to do cross-fertilization between projects from different member states, but also having the possibility at the sectorial level to have an exchange of experience and common projects between entities. We're, for example, are discussing with the Competence Center, with the member states, in the possibility of having a multi-layered community. As you know, I believe that it was mentioned to you before or yesterday that the work of defining the rules for the community, it's on its way in terms of progress. The member states are now discussing what are their views in terms of establishing the Competence Center community. And we see the importance of having a community that it's not only a database, but it's something that we can explore and develop on top of it. So what I see in terms of the next steps, as I mentioned, from my work, what I'm trying to understand is what are the needs from this community. What are our needs? How do we want to work? What we want to do together? What are the needs? How do we define it? Who should be in? How to reach out to them? How do we progress with this? How do we build a stronger community? I think that, at least from our perspective, being at the advisory, being at the governing board of the Competence Center, we'll always advise that the starting point, and that is our perspective, the starting point of the community should be at least the 4 pilots. And I believe that it should be the basis of establishing this community, since this community has been working together for at least for the last 2 years, if I'm not mistaken, and I think that we should leverage from that. The second aspect is to be able to understand who is not in these 4 pilots, and we should call. We need to understand who is not included, and we need to bring them in. We should look at the atlas and identify them and understand them and being able to attract them. And that is a very important point. If you've been working together, there are many others that don't understand the value of being part of this community. And we need to offer something to them. It's not only about money, it's not only about funding, but it's the perspective and the opportunity of us working together as a community. And there is another thing. Atlas is not, first of all, it has its own challenge in terms of maintenance. As we all know, databases have this problem that it's very nice to set it up, but then we need to understand how we're going to maintain it. But from our perspective, at least from the work that we're already undertaking, is that we want Atlas to be our base, but we want interlinkages. We want this database to be linked to the member states, directly to the research organizations. We want more information there. We want information to be shareable, that could be actionable. We want to use the network to be able to interact in terms of the community, to understand what ENISA is doing, what is the work that ENISA requires in terms of information that we're able to share with the community, so that the community can also help ENISA, and ENISA can also help the community by promoting the work of the community. So that interaction for us is critical. and we are putting that in terms of our work program. And at one point, it will be important for us, once we have all defined in terms of how we want this community to be structured and to gain force, is how we continue growing this community. How can we continue making sure that the community developed a stronger basis? And one of the aspects that I've discussed with different members is that I believe that the community doesn't need ENISA or the European Commission to tell how this should be structured and how they should be organized. It should come from the community. You see that in other communities, that people are willing to work together and to discuss and debate. It should be the community itself to get organized. Now, sometimes, most of the time, it's not easy. It's more easier to say than to implement it. But in this case, specifically, there are two fundamental things that could help triggering and building this stronger community. First of all, it's ENISA that is a partner, and I'm here today just to stress this to you, that you can count on us to support, but we're not going to build the community. It will have to be the community building itself. But we're here to support. We can help mobilizing, we can help facilitating, but we're not going to take the initiative of organizing any community. And I think that is even important because the Competence Center, it's an opportunity for all of us. It's an opportunity for us to have access to funding to support our projects. But even more than that, it will pave the way for us to continue making a stronger community and for us to get used to work together as one union on cyber research. And I believe that's all.
So, thank you very much.
You want me to take the questions? If you want, I can take the questions. And I would like to make it very, very interactive. Please just ask anything. I'm here just to try to respond to everything. Don't be shy, please.
Yeah, I'm not going to be shy, indeed.
I know.
Yeah, I mean, I think has been quite interesting your presentation because it's a little bit, you know, you were not here yesterday where we have all the presentation from the commission, from some others, etc. And really for me now, I mean, I try to, I get a little bit confused. Just I must tell you in that sense because first. When we're talking about community, in certain moment, the idea was, okay, the community are created at the national level, and then something will be done at European level. And it was like responsibility of the national centers to try to create their community at national level, and then, I mean, something will, depending on what there will something at the European level. Now, my understanding from your side is the other way around. Is the community really at the European level? I don't know what is going to happen at national level, I would say, but really the importance is the community at the European level. Sorry?
Closer to the microphone, please.
Sorry?
Closer to the microphone.
Okay. So what I'm saying is that at the end you need to, I mean, it's a little bit strained, I was saying. Indeed, I mean, one of the comment yesterday up here was that already there is a working group 1, I think, in the center that already is creating the protocol to create these communities at the local level, I would say, or not the rules to admit the partners at the national level. But my understanding was already that means that something will be created at national level, I would say. But again, my understanding now is that you're talking more about something more European level, I would say, in some sense. So maybe just to get a clarification there, how you see the interaction, if you like, of this kind of two communities that can appear in certain moment, I would say, in some sense. And the second is that you mentioned that one of your role there is to foster, no, the research agenda, I would say, in some sense. My understanding is this is also part of the, yesterday they talk about working group 4 inside there, okay? So where basically we're supposed to create that. I mentioned that because indeed, in the next presentation, you will see the work that all the pilots already have done with the JRC and with the Commission to create a common roadmap. That my understanding, this is common roadmap, is a little bit something like an initial research agenda that was created in that way. So for me, it's strange that you were not on that meetings, in that discussion. So I don't know why. Maybe it's because I said you are new there. But I think it will be good to have this also perspective, because my understanding is your role is to, ENISA role, I mean, is to foster, to create that kind of initial research. So maybe just to get a clarification there, what will be the connection of all this, I was at working group 4, ENISA, what we have done as a roadmap, I would say in some sense, just to understand better how things will proceed starting from now on. I was saying something.
Right. No, thank you so much. That's a very, very good question, and I think it's I think that, in terms of clarity, sometimes things look very dispersed in terms of and try to figure out what is happening. ENISA is actually, as I mentioned, advisor to the governing board, so we're both in working group 1 and 4. But despite that, those working groups are from the member states, because they are the ones that represented the governing board. ENISA is the cybersecurity agency of the European Union. Our perspective is European. There will be, and that is my perspective, there will be communities at a local level, and there will be communities at the European level. We're also in favor that we should even consider communities that are sectorial, because they are also discuss topics that are very specific on cyber. And we also consider that it could make sense for us to look at sub-regional, because there are member states, like for example my country and Spain. Portugal and Spain go work in many projects together. So maybe it could be an option to make a region of Portugal and Spain, or for example Greece and Romania. I don't know. So there are, there's a lot of things still to be discussed. From our side, and in terms of our mandate, and in our mandate there's no reference in terms of the competence center, but there is this idea that we should be involved and should partner with the research and innovation community. And in that role, and unfortunately we only restructured last year at the same time that the competence center was being established, but it's, I believe that for us there is a role to play, because we see that the cybersecurity community needs to get prepared for what is coming. There is this great opportunity with the competence center. Of course, the competence community will be very formal with very strict rules or specific rules to establish the community. As you were saying, the working group 1 is discussing exactly that at the national level, but there will be discussions for the European level. But what I'm talking is beyond that. This community needs to feel as a community. That's my view. I've seen that in other communities, and I think that there's an opportunity now for us to create the cybersecurity research and innovation community in Europe. People that want to work together, people that want to build something together. And of course you could say, but this is just an intention and it's a good idea, but I think that there are, I think that there is a momentum now because of the 4 pilots that are ending. I don't know if they're going to be extended. It's not my but I think that is an opportunity. There's a lot of people motivated to continue working on these things. I'm not saying that ENISA will force or will be the one creating this community, but what I'm trying to discuss with different members from this community is the opportunity. Let's do something together. Let's meet once a year. Let's, let's understand how we can, let's work on ideas together. Let's develop those. You mentioned about the roadmap. Unfortunately, we're not invited to those discussions. And anyway, but I know that I had the opportunity to look at the work that was developed, and I think it's extremely extraordinary, and it's very good. And if we can be part of that and partner and support, we'd be very grateful, because it's our role, actually. It's our role to participate on that and contribute. And if you give us that opportunity to us, even if one day, if the pilot projects are not extended, that at least you're interested in ENISA to continue partnering and at least, to participate in a forum where we can continue, despite that, there's nothing, but we can build on something. And I think that's, that is the intention. That was what the legislator gave in terms of our responsibility. I showed you in my PowerPoint. It's our intention to, to make sure that we have that we mobilize the community, that we involved, and that we engaged. And that's exactly what I'm doing here today.
Well, thank you very much for your presentation. You mentioned at some point the cybersecurity RDI community, well, research and development community. I missed the deployment here in the equation, like saying the deployment community. Or do you think this is something already exists, or that this is envisioned in some way?
No, I believe that the community exists. Yeah. No, totally. You see the 4 pilots, and I think it's such a representation of this community, so well structured. And the only thing that I noticed is that, if you remember, probably you don't know, or if you know, it would be good. You know, ENISA supported the European Commission last year in producing a study of the work of the 4 pilots and EXO. We had the opportunity to see the great work done by the 4 pilots. The only thing that we noticed is that, somehow there was an opportunity that wasn't explored with, for example, with the convergence, and making sure that there would be more convergence between the four pilots, created more projects together, integrated more the community. But I believe that the setup was not favoring that. So I think that there is room for us to explore together with the 4 pilots to make sure that we continue in this trajectory to make to build something. But there is a community, maybe not organized as one community at European level, but I think, I was discussing the other day with someone from the pilots that was telling me, the community should grow from the ones that are able to inspire, that are able to motivate others to get together. And I think that the 4 pilots were able to make those ones that we were able to see them as relevant members of this community, and for them to take the lead and to bring this community together. And the pilots, gave that contribute in terms of putting the people that could mobilize this community on the spot. So we just need to make sure that we. I believe that us as the community, because I also feel that I'm the community, I also did some research work. And I believe that, if we could bring these people and say, let's have another try just to get this community together, that we could get great benefits from that.
Great. Do we have any more questions? No. Maybe I have a last question. Let's suppose that several of us would like to help ENISA tomorrow or the day after tomorrow. What can we do in order to help your work, say, starting from tomorrow?
Yeah, so that's a very good question. So we are now starting to, as I mentioned, to get in touch with different members from the research community. I'm visiting universities, research institutes, I'm visiting companies, I'm having conference calls with a lot of people, not only myself, but also my colleagues from the research and innovation team. We want to understand what you're doing, and we want to understand what are your projects, or things that you already delivered. And that work is very important for us, because we're gathering all that information so that when we develop our own studies, we can make reference to your work. And even we can call you to support in the development of our projects, of our studies. Because ENISA, being the European Union Agency for Cyber, has a lot of visibility from decision makers, people that decide in terms of what technology to use, what companies, what researchers, and we want to give that visibility. So in terms of the work that we're doing now and your involvement, if you could please reach out to us. If I didn't do that already, because some of you already reached out and asked for that support, to tell us what you're doing. Give us information, give us a PowerPoint, give us a PDF, schedule a call. Just tell us, I've got this project, I've got this research work. I'd like to give you some information about that. And what we're doing is we're collecting all that information, we're disseminating internally. What we're doing is we're doing conference within ENISA to present the work that the community is doing, and we're also transposing that into other entities outside ENISA with other EU agencies and bodies. We're also reaching out to entities, And other things that we are also, we just recently, as you know, there is one call for proposals just that finalized last month for healthcare and cybersecurity on healthcare. We're also trying to motivate people, entities, to apply for funding. Also, we know about opportunities for funding. So that's what we want to, if we know about what you're doing, we're able to give you the visibility. We're able just to get to know you and also get you in contact with others that we know that are doing other things that could complement your work, because we got the technical expertise, so we can also support on that. So maybe not from tomorrow, but of course, you know, anytime that you please reach out to ENISA, reach out to me, and please send me information about your projects, about what you're doing. We'll be very grateful for that.
That's great. So I understand we don't have any more questions. Let's thank our speakers. So thank you very much. I think now it's coffee break. Thanks a lot.
Okay, so let's get started, and welcome to this session on road mapping. Before we get into sort of the technical matters, there's a little announcement. At 5 o'clock, there will be the official photo session just outside, as far as I understand. So just that you are mentally prepared for that. So, but Kai will remind us about that at the end of the session as well. Good. So on to the roadmap part of it. The goal of this session is to present you the work that's been going on in the focus group on roadmap, which involved the 4 pilots and also EXO, which was something that's been going on, and produced the first document. So we'll present you what we did, some of the outcomes of it with some zooms on where we are so far with the road mapping. And then I'll talk a little bit about the actual process also as well, because I think it's very important that we also take some lessons from how this work has been done in the different pilots, what we learned, and what's good and what should be kept for future use. As we heard yesterday and also today, there are several roadmap initiatives coming up around the European Cybersecurity Competence Center. And the pilots were supposed to produce some input to that process as well. So I hope we can be useful there as well. So, just to give you a little bit of a history. Well, we started our work in the pilots in early 19, and in towards the end of 2020, it was decided that it would be a good idea to establish a kind of focus group across all the pilots, where we would get together and exchange on how we did our different roadmaps, because the 4 pilots, as it quickly turned out, took rather different, shall we say, routes to how they would produce their roadmaps. Some did it very early, some said it was the end of the project, and so it was deemed interesting to make some discussions and exchanges about how this process could run. Then over the spring and the summer in 21, we worked a little bit more in detail. There'll be a slide about that. Coming up with some cybersecurity challenges that I'll present you in a moment. This resulted in a document entitled Cybersecurity Research Focus Areas Priorities that we delivered to the Cybersecurity Atlas, and which is eventually going to be presented and part of that site. So how did we do it? As I said, there were some monthly meetings where we started by exchanging, brainstorming about what should be this what should be in the roadmap, what each pilot could bring in there. We started out with looking at a small number of priorities, sort of trying to focus a little bit the work. The request was actually, that came from the Cybersecurity Atlas, just say, well, just give us some titles that we could put on the Atlas to make sure give them that. Of course, that was maybe very sort of condensed, but it helped at least focus a little bit the work, and then we started working on them. Being mostly academics, we of course had to write more than just one line. So there was a short paragraph in the document explaining what is the challenge here, and then also, of course, giving supporting evidence for why we thought that was a good challenge. I'm not going to, the document is available. It's around 10 pages long, so it's fairly dense, but that was also a design choice. We didn't want to produce pages and pages. We wanted something pretty concise that could be used by stakeholders. So here is, in a very condensed form, the summary of what we identified as challenges. And this, so we grouped it into 4 blocks. You can see here there's the, shall we say, the trust building blocks, things that you think you use to actually build a system that you're trustworthy. Then there's on top of that, you build what we call trustworthy ecosystems of systems, and there'll be a zoom on that by Evangelos in a minute. So those are the more sort of, shall we say, current technology challenges. There's also aspects we've discussed. What are the actual roadmap for our efforts in terms of education and training and certification, and also how to collaborate. And Theodora will give you a presentation about that after we've heard about the trustworthy ecosystems of systems. And in the end, we also identified a couple of more emerging challenges, emerging developments that pose new cybersecurity challenges, and that, of course, some of the classical ones by now, such as what will quantum technology mean for us. So all that has, for those 4 blocks, are described in a fairly succinct manner in the document that we produced. So I'll hand over to Evangelos, who will give a little zoom on one of the blocks and see what we come up with. So Evangelos, please.
So can you hear me? Yes, great. So this talk is about trustworthy ecosystems of systems. This one, let me see if that works. Yeah, it works, great. Trustworthy ecosystems of systems. Next one. And before I try to explain what are the ecosystems of systems and what kind of research we need in ecosystems of systems, I'm going to explain you how we ended up with ecosystems of systems. And in order to do that, we're going to take a trip down the memory lane and go 40 years back in the 80s, where this computer was computing in the 80s. When you said, I need a computer, it was that, nothing else. It was this box, nothing else than that. That box, it didn't have a hard drive, no hard disk. It had 2 floppy disks. These 2 here are 2 floppy disks. How many of you have seen a floppy disk? How many have used a floppy disk? Yeah, it didn't have network, it didn't have internet. It's not that internet had not been invented. The technology was there. Internet had been invented since '69, I think, for more than, say, 10, 15 years. But the computers just didn't use the internet. So computing was self-contained. There were no interactions with other computers. Or if there were any interactions, they were at the speed of floppy disks. You had to take one floppy disk from one computer and put it in the other. So that was your bandwidth, transferring floppy disks from one computer to the other. So that was computing in the 80s, and systems of systems didn't make any sense. Well, what do you mean systems of systems? There was only one system, that one. You buy it and that's it. You have nothing else. Everything that you have on your floppy disks is the memory that you have. Now we go to the next one, and in the 90s, something significantly changed. People started to use the internet. I told you the internet had been invented 20-something years ago, but in the 90s, people outside the academia started to use the internet because the ISPs, the internet service providers, were made as a business out there, so they could sell access to the internet. So people have started to use the internet. And what did they do with the internet? How many of you recognize what this is? Okay, it's the first browser, or almost the first browser, not actually the first browser, but one of the first browsers, Netscape here. So what did people do with the internet those days? Well, not much. Maybe email, FTP, the web. You could access on the web. You could browse the web, download a document, maybe a song, definitely not a movie, because first, movies were not available, and second, the bandwidth was not there to download a movie. So yeah, you could download a document, maybe a paper, a recipe for if you're a good cook, but that's about it. So the network services were out there, but they were not essential. You didn't use them every day. So if there are several days of you without accessing the internet, well, it was fine as well. And you didn't have internet 24/7. You had to dial up in order to get the internet. How many of you have used the dial-up modem? Dial-up, oh yeah, getting closer to today. Okay, next one. And then what happened? Then in the zeros, that is in the early years of this millennium, people started to depend on the internet. It was not email or FTP anymore, but it was Google, Gmail, Facebook, Twitter, YouTube, so all these services out there, and those services were not only desirable, they were kind of essential. I mean, if you started using Gmail, then if you don't have access to Gmail, then you start feeling it. So it's a pain, it's a problem. So in the early 2000s, those network services started to become essential. Functioning without them was difficult. I'm not saying impossible. You could live a day or two without the internet, but it was difficult. And now, the next decade. In the 2010, people started to put all services online. We're not talking about Facebook and Gmail. We're now talking about banking, online trading, and e-government, cloud, software. Everything was put online. And then actually, while in the previous slide we had the computer that used the network, now actually the network, sorry, how do I go back? Now, actually, the network became the computer. So without the network, you don't have any kind of service anymore. You cannot go to the bank, you cannot access your e-government websites, you cannot file your taxes, practically you cannot do anything. And then, when we had the pandemic, when everything moved online, we realized that without the network, we cannot really function. We cannot go to school, we cannot teach, we cannot receive, we cannot do banking, we practically cannot do anything at all. So, we see clearly a trend here in order to understand what are the ecosystems of systems and why do we need those ecosystems of systems. Okay, let's go back. In the 80s, computer was self-contained. It was just a PC. In the 90s, the internet was a nice add-on with a dial-up, maybe to download a song. In the early 2000s, internet became essential. And in 2010, the internet became absolutely necessary. And the past couple of years, the internet became the only option. You couldn't do anything because you were isolated at home and you couldn't go outside. You couldn't even order your groceries if you didn't have access to the internet. So physical and offline was completely impossible, and in some cases, it was even illegal to go out there and do physical shopping for your groceries because it was after hours or whatever. So it was illegal. It was not only undesirable, it was illegal to go out and not use the internet. So this is how we ended up in systems of systems and ecosystems of systems. We started with self-contained computers, and then we ended up with something, with a computing out there that we don't really understand. So now that we are in this mess, we ask, what is a computer? If you asked that question back in the 80s, it was clear what is a computer. Now, what is a computer? You may tell me that this is a computer, but try use this without the network. It doesn't work. So it's not really a computer. It needs something else. Maybe you can ask the question, what is my computer? How many computers do I use every day? You may say, one, this is my computer. No, 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 no. Once you connect to the internet, you connect to hundreds of computers out there. And if I use several computers, how can I protect all those computers? I don't know. You start asking the questions, the interesting questions that we are trying to answer. And who is responsible for protecting all those computers? And finally, how can I be protected? How can I be protected from the computer? Not how can I protect the computer, but how can I protect myself from the computer? Okay, this and this. And now we come to the main topic. Now I understand how we ended up with that figure down there with the systems of systems. Now we come to the interesting questions. How do we secure those systems of systems, those ecosystems of systems? And we have identified two main topics there. The one is platform of platforms, and the other is infrastructure protection. The first slide is platform of platforms. The first research direction is cloud infrastructure vulnerabilities mitigation. Cloud? What is cloud? I told you in the 80s we didn't have the cloud, in the 90s we didn't have the cloud, in the zeros we didn't have the cloud, but in the 10s we started using the cloud. We started putting all our data out there. We started to put all our computing out there. And out there is just a computer. It has vulnerabilities. How do we mitigate the vulnerabilities? And mitigate is a life cycle thing. It's not how I eradicate the vulnerabilities, but I really know that even if I do eradicate the vulnerabilities from there, there are still going to be vulnerabilities out there in the cloud. And the worst thing of them all is that I don't know what vulnerabilities will remain in the cloud. And I have to protect myself from something that I don't know what it is. Then untrusted IoT, untrusted environments. When we're talking about cloud, we're thinking about those big, massive data centers that have lots of computing capacity. But now we have all those little tiny devices that connect with each other, and we call it the IoT, the Internet of Things, all those tiny things out there that connect to each other. And we don't know what kind of software they run. We don't know what kind of vulnerabilities they have. We don't know how to make them secure, how to harden them, and how to protect ourselves from them. Multi-cloud edge and IoT, and massive connected IoT ecosystems and life cycle management. When we're talking about billions of these things, it's not 1 per person, it's 10 per person or 20 per person. So we're talking about tens of billions of those things. And life cycle management, because I usually say that security is not a product that you buy. Security is a process that you follow. Of course you need to buy the product, but you need to follow the process, life cycle management. Of course, with the product, you buy an antivirus, and it works for a few days fine, but then a new virus appears. Then you have to update the antivirus, and you have to update your process as well. And the infrastructure protection. When we're talking about infrastructure here, obviously, we include critical infrastructure protection and resilience, like electric power, water supply, energy supply, things like that. But we also talk about traditional infrastructure, like security across value chains, supply chains. How do we protect those? And trusted information sharing and collaborative threat intelligence management. We talked about this earlier this morning, and the issue is the following. When you are doing cybersecurity, each one of us has a tiny view of the big thing. Like each one of us has one piece of a big jigsaw puzzle. And one piece doesn't give you any information. But if you pull all the pieces together in the right direction, then you started to get the big picture of cybersecurity out there, the big puzzle out there. And why are these important, in addition to being intellectually stimulating, why are these important? And I think we are now used to having ecosystems of systems. I told you, 80s, 90s, zeros, 10s. There's no easy way back. I mean, we are stuck with ecosystems of systems. We are stuck with platforms of platforms. We cannot go back to the 80s. Of course, you can buy an isolated computer, but you can do very little things with the isolated computers. And COVID has shown that online and cloud and edge and fog is the only option. There is no other option. ETSAP used several computers and software modules, and lots of those computers and modules have been developed outside Europe, or because this is a global world and a global economy. How can you make sure that you trust those modules, or you use those untrusted modules in a way that it cannot harm you? This is the European digital sovereignty we're talking about. I think that concludes my presentation, and then it's Theodora.
Thank you, Evangelos.
Okay.
I suggest that we'll take questions afterwards. Yeah. So I'll just hand over straight to Theodora, please.
So thank you very much. Can you hear me? Yeah. Okay, great. So let me say that I will be focusing in on this left side, the governance and capacity building, let's say, dimension. So I'm here kind of representing Professor Todo Tagarev from ECHO. I'm also from ECHO, who was the main contributor to the road mapping focus group on these dimensions. So this is kind of the less technical dimension of all the others, and I will not talk about what we developed in ECHO in terms of the governance models. I think this was discussed yesterday. I will also not focus on the particular ECHO roadmap, which was presented this morning by José. So this is the consolidated view across all 4 pilots. So as you can see, we have three main priority areas, which are listed on the right. So what is the goal here? The goal is to try to identify the priority areas that need research, more research to be performed in the next years. Of course, this was done by the pilots during the last 3 years, and this needs to keep updated given the evolving landscape. So what will such research allow us to achieve? First of all, given all the available cybersecurity competencies and capacity, it will allow us to obtain an overview. And given the overview that we have about such capacity, to organize it and then enhance it. I think this is very much related to what has been discussed also earlier by the Cybersecurity Atlas and also the ENISA initiatives. Moreover, one of the other dimensions and priorities is to certify such competencies, products and services, and of course the ultimate goal is to be able to respond effectively to all evolving challenges. Okay, so let's start with the first priority area that has been agreed among the 4 pilots, and that of course is that of collaborative networks. And the current situation is what we know and what we have all experienced through our participation to the 4 pilots and through the European Competence Center that will come in the future. So, of course, there is a growing diversity and sophistication of the cyber threat landscape, and there is a need to integrate diverse competencies. So it's not only the technological aspects, but also the human aspects and the financial aspects. And this is becoming so complex that cannot be dealt with and addressed by a single organization or even by a single country. And that's why we need such collaborative networks. And what is the research focus? So what we need to focus on in terms of research is how to develop methodologies and governance structures for establishing efficient and sustainable collaborations among a variety of organizations. I think you can all agree that we have done that to a large extent within the 4 pilots, and the idea is how to move forward and leverage all this knowledge. Then, of course, the challenge that we have all dealt with is that we are dealing with diverse contexts, both from organizational perspective, but also legal and also cultural, of course. And the research should focus on understanding the requirements and designing and implementing effective norms to support such infrastructure and governance models for such collaborative networks. One of the very important aspects is, apart from all the technological that have been discussed in great detail, is of course the human factor, which is quite critical. And there's of course a growing demand for cyber security professionals, but this should not be the only focus of the education and training. So we need cybersecurity education and training, both for other personnel in their professional context, but also of citizens, and also all the way to the various levels of let's say, governance and policymakers. And so one of the research priorities that we should focus on is to try to achieve a shared understanding of the involving requirements that dictate the competencies of professionals. So given that the cybersecurity landscape is changing constantly, we need to have the appropriate mechanisms to research what competencies are needed. So we do have a mapping, let's say, at this point in time, which is the Cybersecurity Atlas, but this has been done at a specific point in time, and we need to be able to update this and to be able to also forecast and what the competencies that are needed are. Moreover, we need to be able to enhance the competencies, both, as I said, of cybersecurity professionals and the general public. And to this end, of course, for cybersecurity professionals, the cyber ranges is one of the instruments that is there, and all the pilots have researched extensively into the cyber ranges and their federations. So in that way, the federations allow not only to deal with simpler scenarios, but also more complex scenario that cannot be supported by a single cyber range. And moreover, federations of cyber ranges, including the federated cyber range by ECHO that we are contributing to, allow to reuse various training scenario and be able to monitor the performance of the trainees. So the last priority area that the 4 pilots focused on and consolidated that there is a need for more research is the certification process. And of course, we have discussed during the last couple of days that there is a need for high confidence to a particular product, process, device, and so on. And the way to achieve that, one way to achieve that is the cybersecurity certification. And as Evangelos mentioned, this is becoming more and more important given the interconnectedness of all these devices and processes and services and so on. Currently, the evaluation process is quite complex, as we know. So there is a need for research, for further investigation into how to make the evaluation process simpler. Of course, there are standardized approaches for the certification, but there is no kind of a meta level of, let's say, of standardizing the actual process. And of course, this is a kind of life cycle, so it's not only the actual end product, but it's also a process of design and development that need also possibly to be certifiable in order to reduce potential harm. So, thank you.
You can put the slides back on, please. So, The last part of the presentation is dedicated not so much to the actual roadmap that we came up with, but rather discussing a presentation about various roadmap processes, ways of creating a roadmap. So here we're taking two examples. There's one from Concordia that was supposed to be presented by Arthur van der Mees, and then I'll present something about it, but he couldn't be here, so I'll try and do Arthur's part as well, taking some of his slides. And then I'll present some of the work that we did in Sparta. It's not going to be taken as sort of the final word on this, but more to spark maybe some discussions about how this could be done. So when we look back at the Sparta roadmap process, for instance, it started out as a mission-oriented process where we said, okay, what do we need to do in order to strengthen sort of digital autonomy in Europe? The roadmap is definitely technology-focused, and I'll come back to that point, especially when I talk about the Concordia roadmap, which takes a wider perspective. Looking at identifying in particular technological white spots, where do we need to work more in order to fill that mission. The design process was, we wanted it to be iterative and also quite agile, so there will be several phases where we built sort of progressively what ended up being the final roadmap. But it involved phases where we reviewed what we had, we came with discussions, got input, new input, and adjusted it. So this iterative process. It was also designed so that it was very open. We wanted the whole research network to be able to provide input, give their point of view to what should be in there. And then there was finally, because it was this lots of information coming bottom up, it was also deemed desirable to have a sort of a governance process that should be able to direct this creation process of the roadmap, discuss the input, analyze it, and treat it. So the roadmap committee sat in a fairly central position in the Sparta project, where we had interactions with work package leaders, also with the associates, for instance, and the other pilots, and then discussions with the strategic directions, and in particular all the research programs, where we discussed in several iterations what and how the roadmap should be updated as science progressed, if it were. So the first roadmap, the version 0 of it, was built identifying white spots and also asking out in the community, so the Sparta community, well, what are the challenges? And this actually started even before the project, the network started. You can probably maybe still remember that back in 2018, the spring of 2018 was quite hectic because there was this call coming out for network pilots, and they had to be delivered fairly quickly. So what we did was that we asked out in the sort of Sparta partners to say, okay, what are the challenges? We got about 60 suggestions for things that we could do, which we then sat down, analyzed, grouped, prioritized, and identified in sort of 5 these initial challenges, the Sparta programs, that then formed sort of the, shall we say, the technological part of Sparta. Along with that, there was this analysis, as I said, of white spots, and that's tribute to, in particular, Fabio Martinelli and his group, who led this work on analyzing existing roadmaps, both national and also international, available at that time, to see what was dealt with and what was not so much discussed in this roadmap. And you can see some of the areas which are quite well treated, those in green, and other areas where we certainly which has received less focus. And we used this, we analyzed this along the JRC taxonomy that we heard about earlier today. Then work went on, and we also worked on the roadmap, and we concretized that into a more precise roadmap that involved but was not restricted to what was going on in the Sparta project. So in the project we identified, shall we say, these 13 mission programs, which we deemed was to be programs where we needed to solve problems in order to make advance towards achieving the overall mission goal of SPARTA. And so you can see, including there, you have some of the ongoing SPARTA programs, but also other areas that we thought it would be very relevant, that was necessary to keep in a roadmap. And along with that, not only did we sort of list challenges, we also gave a tentative timeline for that. That's of course quite speculative, but we nevertheless thought that that was reasonable to do. In order to structure that work, we have set up a template for describing these challenges, including a SWOT analysis in sort of a EU perspective. What are we good at? What are we bad? Where do we need to improve? And so on, which gave some structure to this rather long document. Once we had that, then the next step was to say, okay, we can't do everything at the same time. How do we prioritize? What should we do first? What can wait a little bit? And again, this the approach we took to this was to engage the community again. And because COVID had arrived at that time, well, this was entirely digital. What we did was that we asked out, give us, here are some of the challenges identified in the roadmap, which one should we do? Collecting this feedback then allowed us to give us some tentative priorities. So, and at that time it was, we saw that, for instance, the certifiable AI systems and the trustworthy software was deemed very important. Of course, all these topics here are important. It was more a question of how to actually, where should we start, and in which order to address these issues. So that's conducted in a way based on sort of engaging with the community and discussing their feedback on that. So, what did we learn from this process? Well, as usual, there's no one-size-fits-all. There are several sectors here that you need to cover. We focused very much on the technology one, but of course the other dimensions should also be addressed. We were mainly focused on the technological aspects of it, and I acknowledge that sort of more analysis of verticals can be done. What we think is that we found that this process will be used in SPARTA to start out with a mission, sort of that give guidance, that focus the work, because otherwise it has tendency, this roadmap work can go all over the place. We think it's important to keep it open, so that, I mean, the networks is populated with the experts, so that's why you want to hear them. Should not be a few people sitting somewhere up there saying that we want to do this. It's very important to involve the experts in this. And it's also very important to see this as a process, not something that you set out and then say, okay, now that's it. Plans are done, can't be changed. No. This roadmap should be reviewed based on how you advance and also how you see as basically the process, the progress that you make. Otherwise, for certain things could be done interactively. These surveys proved to be useful, but it was also quite clear that we were missing out on quite a lot of things because we couldn't meet physically. These roadmap discussions, we had some in the beginning. They were very productive. As soon as this went online, well, I think we lost some of it, clearly. Finally, we call it a governance structure. That sounds a bit heavy-handed, perhaps, but I think it's important to acknowledge that this roadmap work has to be sort of guided and work. It is work to build these roadmaps, and it's continuous work that you have to interact with your community. So some kind of governance structure for the roadmap is important as well. Right. So that's the SPARTA experience, and then I have some slides from the, as I said, from the Concordia, from Arthur, which provides another point of view of road mapping. So SPARTA's roadmap is fairly technologically oriented, but as we heard and we already discussed yesterday, maybe it's also very important to take other dimensions in particular the human dimensions, the users, and other into it. So here is another view of road mapping work that they've put forward by Concordia. So again, we're still on the, shall we say, same page when it comes to the overall mission, building and sustaining European digital sovereignty. And this has to, again, involve, well, there are four parts in this work. There's the research and innovation, of course. There's the education and skills that we've seen. And then also taking into account, and they have been very good at this in Concordia, the economic development, sort of the industrial view of it, and the collaborative efforts as well. So the point of view that it has taken in this roadmap is to take the stakeholder-centric perspective. So what does each stakeholder here, what is his or her perspective on what is important? So as I said, and instead of having the technological-centric, let's try and look at it from a stakeholders. And who are the stakeholders? Well, you can have the humans or societal, use case-driven centric, and the technology-agnostic approach to it. So very much complementary to what we heard just before. In the first place, you do an analysis of what is where you are. So Arthur put this in a formula, I think. It says state of the art minus state of practice identifies a gap, state of play, sorry. So this is how things are done currently. I think this is what we know, how we could do it. And then there is a gap between there, and how do we fill that? So that is what we use. And then there is this, what you call multi-angle co-creation. And in the Concordia, the roadmap looks at quite a lot of perspectives. So there's, still, as I said, the research and innovation, education there. And then the additional perspective like economic and legal perspective. And then we've heard about the certification and the community building. And when you look at who could be interested in this, then we have, again, different angles from where you could start analyzing what are the priorities here. For instance, we have the investors and financiers. Well, of course, first of all, the users or the customers who wants to pay, but also seen from the suppliers how to secure the whole ecosystem there. There are many aspects that have sort of many angles that have been developed here, and I think it's an important message to say that roadmaps can also be built, used from these different perspectives, yeah, that's the point that Arthur wanted to make. So I'll stop there. That was sort of my best rendering of what Arthur probably could have said much better. That ends the presentation, and now I'll be happy to have some questions or discussions about how to do road mapping for the future. So, Afonso.
Thanks, Thomas. So first of all, thank you very much for the three speakers, because it was really good to see this very clear how this is developed in the pilots. I have actually, if you allow me, it's a comment more into the governance part of it. And so if there's something that my years at the Commission at the cybersecurity unit taught me, is that there's a big problem in that 10th point of Concordia's last slide, that was the stakeholders that are law enforcement agencies, intelligence services, and defense, because they have a point of view that's completely opposite from ours: research, innovation, industry, market. Completely opposite. So Fabio Martinelli was also at the security advisory group that we had between DG Connect and DG Home. And the conversations we had in that group were, I mean, absolutely ethereal, because we were trying to push for cybersecurity while the others were trying to push for cyber insecurity. And they are the purse holders. So they are those who are actually deploying the systems. They are funding the research that we are trying to push for them to fund. And while we don't have a clear research on that specific point of the opposition of views between them and us, the cybersecurity issue will never, ever be solved. Because, should I remind you that the NSA just recently promised not to introduce backdoors in the new cryptography tools? I mean, that's the NSA talking, right? So they promise, I mean, whatever they promise, right? So you know that all the cryptographic tools that are deployed today have backdoors introduced by at least the NSA from the United States of America. So what are we talking here about researching cybersecurity if the very tool to protect the systems with cryptography has backdoors put by national governments? So I think that in any kind of road mapping, the governance point has to be present and prominently present, because, as I said, as long as we don't solve that specific crux, we will never have cybersecurity. We may have research in cybersecurity, we may have funds in cybersecurity, but we will not have cybersecurity.
Okay, thank you. I think that was more of a comment, but I think it's an important point. And yeah, no, it's right, and which reminds me that when we talk cybersecurity and analysis of that, we should always do it relative to some kind of attacker model, I think. And so that I think all research in cybersecurity should be with respect to what is your attacker model. But the governance issue is yeah, definitely also pertinent in that sense.
Actually, I was reinforced the point of Afonso. There is cybercrime. There are all the things related to law enforcement agencies that not sure if those are covered and from which perspective we want to cover. But there are areas, I think, even related to cluster-free, when there is a secure society and so on and so forth, fighting cybercrime that could, let's say, be related to what we are doing. So I don't know. In SPARTA, I'm not sure that we have it. And it is a point that what Afonso is saying, or trying at least to have some sort of perspective in this direction could be worthy.
You mean you suggest to reach out to them and understand more their...
This perspective, there are law enforcement agencies, there are governmental agencies that are trying to do something. These are actually actors. The threat model you mentioned, but these are things that are happening, and in our 3 on the 4, it could be something that could be considered. At least I think it's very worth of discussion.
Right.
Can I ask the next question?
Sure.
Okay. So I'd like just to start by saying that I'm a great fan of this work. We also took the opportunity of transposing that to the advice that we prepared for the governing board in terms of the next steps, and also on an overview of the work of the 4 pilots and EXO. I think it's a methodology that we can use it in different dimensions, but it establish the basic principles on how we should look at how to develop road mapping. And I think it was a great effort. I think that we should promote it and be able to make it even extended to other areas. But I wanted to ask 2 questions in terms of it. The work that you did in terms of using this methodology was basically looking or road mapping to existing technologies and processes. In Europe, we need to have also a sense of priority in road mapping for future technologies. And we need to also excite our community to research and be able to explore things that are not already mainstream or not or even emergent, but they are future technology or future trends. And I think that the road mapping should also give us that dimension. I understand that at least we have the methodology, we have the basic principles, and that is an exercise that, in my view, we should do. And my question is that considered in terms of a plan or for the pilots to conduct such an exercise? And my second question, very quickly, is it in terms of how do you see, in terms of the road mapping, exploring situations related with concrete, deriving from the road mapping into concrete actions or call for action, on how will you be able to transpose that? For example, one of the things that I've noticed is that it's too much focused on research and not so much on innovation. One problem we have in Europe is that there's a lot of research, there is a lot, even development, but somehow we're not so good as other blocks in the globe in taking that into the market or even explore it. Research is already important for us to develop knowledge, but if the roadmap is able to take us to the next level, for us to generate the next product made in EU, or the process, or even a service or something. Thank you.
Yeah, no, that's a fair point. So for the first point, how to roadmap sort of the emerging or maybe future technologies, as you say. We did have that on the agenda in SPARTA, and afterwards I'll ask the others pilots what they did in that. But so trying to do some kind of horizon scanning for technologies that sort of are emerging and try to understand what were the security implications of that. I must admit that we didn't get that far with it. There is a part of this common roadmap where we had some future sort of emerging technologies, as I said, the next generation. Where we had tried to make an analysis of what the implications of quantum technology could be, what will be the next generation, after next generation of communication infrastructures and implications of that, and also in terms of architectures. But I think it's basically a very difficult question. So we made some attempts to it, but difficult and important. But, I don't know if in the other pilots, what you did with the emerging and future technologies.
Yeah, I'm not so much going to comment on what we do in the pilot, but then question. This is a very interesting question, very important topic. But I just want to comment about what happened on that roadmap. And on that roadmap, we wanted to have a short list of priorities, clear. Length was the most important issue, to create a short document that would be easily understood, say 10 bullets. Actually, we started with 1 page or 2 pages, just 10 bullets, no more than that. And then for each bullet, we added a paragraph, something like that, and we ended up with 10 pages. Now, what you are saying, I think, is the great next step. So after that, after we are done with this work, we may follow exactly what you described with, say, future priorities. Currently, we just wanted to produce 10 bullets that can be easily communicated, easily understood, and easily digested. I think that is why we don't have, say, the extra future work. Although we have some future, like quantum computing. Quantum is not really here. It's, yeah, just around the corner. But we don't have, say, the future, what will happen at 2030 and beyond. We don't have that. Yes. Theodora.
Okay. Just to comment from the perspective of ECHO, again, the road mapping in terms of general priorities was not done for so far ahead in the future, but what we did develop in ECHO was 2 what we call technology innovation roadmaps that were quite, though, a bit focused on specific areas. So that referred to technologies that are not widely used today. So one of them was how to support CISOs using AI technologies. So this is a bit kind of emerging and a bit to the future. And the other was, again, how to use AI for cybersecurity in autonomous transport. So this, it was indeed very challenging to produce a roadmap for the future, which was quite all-encompassing. That's why we focused on two specific, what we call technology innovations, to be able to generate something like that. Okay.
I think that. Okay. Any other questions, comments?
Okay, well, first of all, thank you all the opponents for the presentations. It was really interesting to see the roadmap. I see a lot of research roadmap. I just the same comment you may, if you've been here the same days, these days, you know probably what I'm going to say, is that I'm always insisting in the deployment, right? I'm kind of worried about how to all these developments we see can. I mean, I would like, not worried, but I would like really to see them deployed. So I don't know if maybe this is not the session, maybe we talk about this in another session, but whenever we talk about the roadmap, if you admit the comment, I would really, I think it's important to think about the roadmap of exploiting or deploying whatever you've been developing, and just the comment of saying that please don't forget how this gets into it. To put an example, someone talked about researching the market needs. Maybe I see that this is something that can be done recursively in time by deploying a system that does this. And by a system, I mean a way to do it, not as a research effort that's done in a project, but as a systematic methodology deployed for doing that. We are doing that in the agency for our own region. Maybe we can help in deploying that at a higher level if someone is kind of exploring that area, maybe. Another one, well, the other one is a comment, maybe reacting on what Alfonso said. I don't know if this is something you want me to say or we want to move forward in the presentation. Because I talk too much.
Yeah, no, I lost. So the thing about deployment. So I can only say that. So it was very. I talk very much about research here. If you look into the SPARTA roadmap, then there was actually a timeline with it, and some of it is far sort of over the years with several sort of milestones in there, saying that okay, these are the things that we want to achieve in order to arrive at a solution that in the end should be deployable. But yeah, but it's true that I didn't stress that, but you will find that as well. And yeah, so the other question.
Yeah. Thank you. Well, no, the other was just telling the experience of this reacting on the law enforcement versus cybersecurity deployment thing from the small regional government agency I come from. Maybe I have something to say on that. What we do, the way our government kind of not solve it but tackle it is we split it. What is the law enforcement from what is the cybersecurity capability or deployment into two separate things. Of course, then it becomes a rat race in terms of if you want, it becomes a race of capabilities between, it may become a race of capabilities between law enforcement and cybersecurity deployment. The way I like to, well, you know that I'm here, so I'm in the cybersecurity deployment one, as you may know. The way I like to think about is that I have with me all the market. I have with me all the community who wants to deploy. So this is something that the community is with the ones that want to deploy. the other community, the community of agencies which have, I mean, the other agencies, the law enforcement agencies, which want to find the exploiter, want us to be vulnerable, this is a different community. Maybe they have a different, more capacities, maybe they have, who knows, let's hope not, but we have to somehow build a community that's able to face the threat if that's an actor that represents a threat. And that's
okay. I think it's time to conclude this session. I think I'll just conclude by saying that I hope that, well, no, I'm sure that road mapping will continue. We'll continue working in the focus group. I encourage you all to engage in it. It's important that we, the community of experts, give our contributions and make our voices heard. And I certainly hope that the road mapping that will go on in the future in the ECCC, that it will also have a process that involves sort of, shall we say, the base. And with that, thank you very much for your attention. And there's chocolate to you too.
No, this is for you. I already have one. This
yeah,
is for you. No.
Two.
I'm giving it to you. Okay.
And the Kai, it's over to Augustin.
I'll try to not keep you too long. There's a photo and there's the apéro afterwards. So first of all, I want to thank you all for today, for coming. Thank you, CyberSec, for all the organization, the Essen representation also for organizing. So it's not finished, but for today at least, I'm thanking everyone. So yes, small summary of the day and what we learned and what we discussed today. Well, I think we jumped quite fast into research and what we actually did, the core of the pilot, because we talked meta yesterday, we talked of governance, we talked a lot of stuff, but the core of what we did is research in cybersecurity, and that was actually the first two talks session of the morning, and quite interesting with how every pilot organized their research, what they did. So that's actually the core of our core of the pilot, so that was quite interesting. And then we went with the vertical, we went at sea, we went in space, we went with vertical on telecom, hospital, connected buildings, so we have plenty of different opportunity to showcase our results, quite interesting everywhere. I'm proud of our SPARTA result, and I'm sure everyone's proud of their result, and quite really interesting here. So then afternoon started with community discussions from JRC and from the Atlas perspective, then from ENISA. So quite insightful there as well on community, and shows also there's, I guess, quite a lot of work still to remains here, and we'll do it together, so that's nice. And great. So community building is quite focus here and quite important because, well, we see then with the next session, roadmap, and we see that community is actually bringing the inputs here. So that's how I see the link here on we can't do roadmap as fixed something, and then community is the one doing the research. So doing the first two sessions, we are the community on part. And then we are also the one giving the insights, giving the roadmap insight, and it's not a fixed process. So yeah, last session of today just finished. It was on roadmap. And so we had quite insightful work from the 4 pilots on what they did in their roadmaps. So good presentation on floppy disk. Might have been some other stuff. I stopped there, but it was maybe a bit biased to young people like me. No, I've seen a floppy disk once. Okay. But yeah, no, very interesting presentation showcasing different approaches in the roadmap and showing the work done to bring that all up together, to show that it's not, that it's an agile and continuous process of road mapping, of prioritizing everything and thinking in the future, in the future of what are the next challenges in roadmap. And that's what we need to do with the community. We need open to the community. We need an open roadmap to the community, and that's how we build a great roadmap, a great environment to do cybersecurity research. So I think that will be my quick summary of the day, and I will thank you once again, everyone, for coming, and we can go take a picture together.